Test, test. Test, test, test.
And I'll go back there and make sure it's.
Test, test.
Test, test.
Thank you. Hello, can you hear me? Good morning, everyone. We have a really small crowd here. I guess after Linus's keynotes, everyone's still there. So only people who are really interested in that came. Just to clarify, I see Yocto experts in the back. So who is Golang expert here, or came specifically for Golang? Or most of, okay, just a few. Just a small disclaimer, we are also not Golang experts. So if you have Golang questions, we probably won't be able to answer that. Just to start, so my name is Vyacheslav Yurkov. I usually go with the first name Slava, so everyone is able to pronounce that. My background is I use Linux since the year 2000, and I contributed to various open source projects, Linux kernel, trusted firmware ARM bootloader, and I try to maintain the overall FS classes subsystem in the Yocto project and OE core. And those are my contact details if needed. We do that presentation together with Lucas.
Yeah, hello. My name is Lukas Funke, or just in brief, Lucas. I have also some years of experience in Linux and embedded systems, and I'm currently working for the company, for a German company which is called Weidmüller, and we are contributing to the Yocto project, to U-Boot, and several other projects. So if you want to contact me, feel free to reach out to me. So I'm going to introduce our agenda today. And first of all, Slava will talk about how C and C++ applications will be built within Yocto, just to line out the difference to how Go is built, which is my part in the later stage. And then we'll talk a little bit about the dependency management in Go, and talk about when was Go support originally supported in Yocto, and what is the current state? How do you get your Go implications to run with in your Yocto image, and our future plans for it. So please go ahead.
So why I chose C and C++? Because we are here talking about Yocto project, and it's mostly about embedded. I think it cannot get rough estimated, probably like 70–80% is going to be C or C++ development. And before we go into that, quick overview of terminology. So what bitbake is, because not everybody comes from Yocto background, some of you more concentration in Go. So we have a bitbake tool in Yocto, which is like a build system and a preprocessor, you can say a task scheduler and execution engine. So bitbake parses so-called metadata or configuration data. And the tool is written in Python, and it uses as an input those instructions which we call recipes. So recipes itself is just a text. Oops. What happened? Sorry. Now we do it again. Now we're back. Sorry about that. So the recipe is just a text file. And a text file with the extension BB, coming from bitbake, and it describes how you build the software. It also describes a set of dependencies you have. It has a specific syntax, which kind of looks like a mix between the Bash and Python. And it can also describe you not only the dependencies on the package level, but it can also describe dependencies between different tasks. So the tasks is also something which bitbake executes. So the recipe itself splits on several tasks. You can have a build task, you can have a fetch task, which fetches the sources from the internet, a patch task that applies different patches. And the granularity is that you can set the dependencies between different recipes and different tasks. So for example, you see that there's a gRPC and protobuf recipe, and in order to compile a gRPC, you need to have the protobuf available. But that doesn't mean that you have to execute everything in order. So you can first fetch the protobuf and compile the protobuf, and then you can already compile the gRPC. So the tasks, the Yocto is able to cache those tasks in order to speed up the subsequent builds, and so-called shared state cache. When we come back to the build systems, and in context of C and C++, you have different of them. You can use just make files, order tools, CMake, Mason, and various of different systems. My example here is based on CMake. You don't have to be an expert here. Just want to provide a brief example. That's really simple CMake file. You build a main CPP file, which set as add executable, main CPP, and you link it against the Boost library. And you see the find package. That's how C and C++ tries to resolve all the dependencies. This is how you build it from command line. And that's the recipe for the C or C++ project, which is doing the same thing. It builds the hello world application, and you see that depends and rdepends, those are dependencies of that application, hello world application. So depends is a build time dependencies, rdepends is runtime dependencies, and do compile and do install, those are tasks that get executed by a bit bag. So Yocto has also a set of classes which can repeat the common functions for you. And in that case, the recipe you saw before is equivalent to this one, because all the work is done in the CMake class. Now, to get kind of a reference and connection between those command line commands and the Yocto tasks. So when you have git clone, that is done by the do fetch tasks. Then you have a configure, as basically when you create a build directory and call CMake, that is handled by do configure task. When you build, it's do compile task, and then you install, and etc. So that's just a simple example to understand how software is built inside Yocto. Now, in the recent Yocto version, and the latest LTS, at least in Kirkstone and further on, there is no network access in the do configure, do compile. So you can only fetch the sources one, get all the network access you needed, and then there's no network access by default. So you see why that's important later. So that's how it works. So all the sources are loaded during the fetch tasks, and then they're preserved in order to speed up subsequent builds. The network access outside of do fetch is possible, but you have to specifically enable that. So all that allows to achieve reproducible builds and speed up the subsequent builds when you need that. I think that was.
Okay, so I slide over to my part of the presentation. Here are two commit messages where Go was originally introduced into OE core, that's right. And it was back in 2017, and there was an additional commit which supports the Go module, the Go mod class. So my first idea was to line out, I've seen that we have just one actual Go like expert, not like me, in the audience. So I want to talk a little bit about Go now and what is so special about Go in contrast to the things Slava introduced. So a little bit about Go. In Go, every application is considered as a module. On the bottom right side of the slide, you can see the module declaration. A module declaration is more or less a file which says what's the name of the module, what is the required Go version to build this module, and also what are the dependencies of this module. So on the bottom left side of the slide, you see how the actual Go implementation works. So you have like functions and package declarations, and you have also like this import statement in the middle. For the C or C++ nerds here in the audience, it's more or less works like an include. In this case, it's including the quote package. So a module can be further subdivided into packages, which are like subfolders of a module. And all packages and all required dependencies are, as I said, declared in the Go module package. So how is this application in this example built? It's built if you type. It's really easy to build a Go application because you go in your application directory and you just type go mod build, and it will download every dependency which are declared in the Go mod file. It will download the actual source code into your local cache from the internet, and it will compile the whole Go application into a single application. So these applications can go pretty big. I've seen applications like 50 or 100 megabytes or so. But the important statement here is it will go to the internet and it will fetch all dependencies. And as Slava said before, okay, we have no internet access in Yocto after the fetch phase. So if you fetch the application, if you fetch your Go application, which you have written in the source URL in your recipe, it will download your application from whatever, GitHub or so. And if you're trying to build it, you will eventually fail. There are two ways to work around this issue, as for now. So you can either re-enable the network access into your compile phase while you're translating the module, or can use something which is called Go vendoring. Go vendoring is like a wacky way around this problem, because when you do vendoring in Go, so it's more or less like a command which you type into a terminal when you're in your Go application directory, and it will download every dependency of your application into a so-called vendor folder. So these are the two ways around it before our contribution to the Yocto project.
Just a small remark. When the original Go support was added to OE core, people had already Go support in other layers, like method virtualization and some other layers. They didn't have that problem because network access in previous Yocto releases was allowed, so everything worked just fine. You just need a Go compiler, Go toolchain, and you're good to go.
Yeah, and it's still a valid way to use it, right? Yeah. If you try to prototype your image or your firmware, then it's still a valid way. But if you try to enable reproducible builds, and if you have like a 10-year-old image or a firmware file or whatever, these modules which you download from the internet may be not around anymore. So we need a way around it. So what is so challenging about it to marry the way Go handles its dependencies in the go.mod file and the way Go handles its dependencies? As you've seen before, that the dependency handling in Yocto is more or less using these depends and rdepend statements, and this doesn't work anymore with Go. So because Yocto is more or less, Yocto doesn't understand your go.mod file. It's completely unaware of the dependencies of your application. So it cannot fetch your dependencies, kind of patch your dependencies, kind of patch like security holes in your dependencies, and it cannot archive the dependencies for you. And it can also not discover any licenses of your dependencies. That's pretty bad. So also, like as I said, you maybe have like embedded projects which are around for 10 or 20 years, and who thinks that the modules from the internet will be around in 20 years? I don't think so. So how do we deal with the problem? So our contribution extends something in Yocto which is called the recipe tool. A recipe tool is a neat tool in Yocto where you can bootstrap your recipes, and the recipe tool is aware of several build systems. So the workflow roughly works like this. You have, on the left-hand side, you have, for instance, a repository, and this may include a make file or a CMake file or an npm package or whatever. And then you put the URL of either it's local or it's remote. Either you put the URL in the recipe tool, and from the recipe tool you will create, the recipe boilerplate code more or less. It will recognize your build system, and it will create the according to your build system, it will create the recipe files for you. So it will, like Slava said before, it will create a recipe tool which inherits, for instance, the CMake class. And our contribution to the Yocto project now extends this recipe tool in order to recognize Go projects. So you see here on the left-hand side, you have your Go project. And on the slide, it's my Go project, but it could be your Go project. And the recipe tool will analyze this repository and say, okay, there's a go.mod file. I have to dig into the go.mod file and analyze it, and I will the recipe tool will gather all the import path. So you more or less the dependencies from the go.mod file, and aside from the actual BB file, it will create a modules file and a license file for you, and also a modules.txt file. The modules.txt file, it's I don't know if I should describe it here. It's just a minor specialty about Go, how the vendoring works. But the important part is that if you use this recipe tool on a Go application, you get actually the modules file, which contains all your dependencies, and the license file, which contains all the licenses of your dependencies. So what's actually so tricky about it? Tricky about it is if you try to fetch, so a module, a dependency in Go is described as a module. It's more or less like a URL. So it says where is your dependency residing, where is the source repository of your dependency. And a little bit tricky about it is that you may notice that, okay, this is URL, but it's not pointing to the actual source repository of your dependency. You have to look up this translation from the actual import path to the repository URL. And you can do it in several ways. In Go, you can go to the Golang proxy and say, okay, I have an import path. Give me the source repository. This may or may not work, because not every Go project is in the Golang proxy. There are pretty much import path in the Golang proxy, but not all. So you may get a 404 error. You can choose to use the Go import HTTP statement and ask the module URL where's the actual source repository, or you can use some sort of regex translation. So the recipe tool in our case will try these 4 ways in order to translate the import path of the go.mod file to the actual source repository URL. And most of the cases, it works. It will also handle the version commit the version translation. So if you're using version 1.0, it will try to fetch the actual commit, which is mapped to version 1.00 in this example. So let's look what you get as an output of the recipe tool, where you will first get the actual recipe. Here you see the source URI, which Slava also described before. It points to your Go project, and it will also include the license file and the modules file, and it will inherit the Go vendoring class. What the Go vendoring class is used for, I will describe later. So, as I said, you get the recipe and you get the modules file, and here we will see an example how this file looks like. So all the dependencies which were in the go.mod file before are now in the modules include file. And so Yocto has several ways to model this sort of dependencies. And for instance, for Python dependencies, every dependency is more or less like its own recipe. And here we decided to go for that we include the dependencies in a separate module includes file. Because you may have really much dependencies. For instance, Kubernetes has like 500 dependencies, I guess. So it's a more clever way to include all the dependencies in the modules include file. So if we look at it, we have the source repository URL, which maps to the actual import path of your Go application. And we have also the modules version, which we require to make use of the Go vendoring mechanism later. And you will also get a license file, which includes the license of every dependency. So why is this important? If you're thinking about like generating an SBOM for your project, if you use the regular Go mechanism to fetch your dependencies, the licenses after the build process will be dropped, more or less. So you have to like preserve the licenses for later use. So you have to have them in your include file somehow. So I want to just get back to the vendoring, because as I said before, the vendoring, if you remember some slides before, the vendoring is some sort of mechanism to deal with the fact that you don't have network access. But using this mechanism here in Yocto, we actually exploit the vendoring mechanism in order to download every dependency which are modeled here in the modules include file to a vendoring folder and actually make use of this vendoring during the build process. So we more or less mimic the vendoring process in our build process in Yocto. And as tests have shown, this works for like most of the projects which are using Yocto. And what you get now is that you're actually independent of the Go infrastructure. So you're independent of the Golang proxy. You can rebuild your Go project in like 10 years. You can even fix bugs in your dependencies. And you have reproducible builds now for Yocto, which is, I think, it's pretty neat. And you also can include all the license in your final image, so you can fulfill the license obligations. So you want to go with the future plans?
Just want to add that it doesn't mean that you have to convert your project to use that mechanism. They always still work. You can still enable network access, or some people, the project I worked with, they just keep vendor dependencies in the repository of your project. That also works, and you still can keep using that. It doesn't mean you have to switch to that approach. And this approach is still not perfect, still requires some more attention. The CV check for dependencies, it's still not there. We're still thinking what's the best way to upgrade your recipe in a more seamless way. there's still one small thing missing to add the SSH support. So by default, we assume that all the links are HTTPS. And last time I checked, the dev tool was also had a small issue that if you want to try to develop your project with a dev tool approach, there's a small path issue which needs to be fixed. So those are plans we have right now.
Yeah.
Anything else? Yeah, those are references and links to discussion to possible approaches, how to handle that. And thanks to Bruce and Weidmuller team for reviews and all the suggestions. Yeah, but that's all from us. If you have any questions. Thank you. Yep. Do you want a mic, or should I repeat the question? Yeah.
So the first step, you said that it works with the mod file. Does it actually traverse the whole network of all of the mod files that get downloaded from your dependency update?
If I get the question correct, the go.mod file includes all dependencies, like the direct and indirect dependencies.
So if you depend on one, you can download something that has dependencies on other things.
Yes.
So it can download the next thing,
Yes.
and it may not necessarily be represented in the go.mod file.
I mean, the recursive dependencies probably.
Right.
Yeah, yeah, okay, so yeah, actually Go changed this mechanism in 1.17, I think, and before the Go 1.17, it was just the direct dependencies, which are in the go.mod file, and during the process, we're trying to update Go or to update the project to 1.17 somehow, if it works. Such that the go.mod file will include all direct and indirect, so the transitive dependencies.
Yeah, I think I haven't tried it before 1.19, so you tried 1.17 or higher?
Yeah.
So before that, we haven't tried if it works with all the Go versions.
Okay. So there's also some issues with Go, and if some multiple projects can depend on multiple versions of one given version. It's usually handled with the incompatible. So the version that it says I need this version is like the minimum. Incompatible means I can't go beyond this because I don't have support or there's a requirement. Does this handle that in any way?
I think the rendering does that automatically.
Yes.
I saw that there were two versions of the same project, and the rendering at least worked in that case.
Okay.
Yes.
Yeah.
Right.
Yeah, so we're trying to emulate the rendering as best as possible, and if the rendering can handle such problems, we probably also can handle this problem.
So it's basically the rendering behind the scenes. So recipe tool tries to do the rendering, but just fetches them at the fetch stage.
Yeah.
Yeah.
So it essentially solves it.
Yeah.
So any further questions? Slava, there's a question.
Nope.
So I was just wondering about recipe tool. Is it part of the Yocto project, or is it a custom tool of yours?
No, it's part of the Yocto project.
Okay.
Yeah. It can handle multiple, it can recognize multiple, as I said, build tools. It can recognize
Build systems, yeah.
C tools, auto tools, NPM, kernel modules, and whatever.
Okay. So before that, it was part of DevTool, I think.
DevTool is a different tool. It's a more tool for development workflow. This was somewhere at the end. Yeah. So recipe tool is when you want to create a recipe or a skeleton for your project. It doesn't mean that it will work right away. So Lucas probably mentioned that you still need some fine tuning when you want to use that. But DevTool is a different tool. It's when you want to create a working copy of your project with all the sources and just work in there. So that's a bit different approach.
Yeah, I can expand on that a little bit. DevTool add will do what recipe tool create does. So all of the logic that has been added here in recipe tool will be used when you do DevTool add on something. It's just that you'll additionally get a copy of your sources, or it'll utilize your source tree if you tell it where it is, and build from there for as long as you want it to. So you can set up a development environment, basically.
Yeah, correct. So one of the dev tool called recipe tools behind the scenes, yes.
Exactly.
Dev tool add and dev tool create, probably. I don't remember the exact.
DevTool add, yeah.
Yeah. Sure. Oh. Thank you.
So, if you are putting in a recipe for a Go project which already does vendoring, have you had any thoughts about how to get the license handling, CVE handling, and all of that in place, or are we just, well, out of luck?
Yeah, if you run the recipe tool on a project which actually has the vendor folder, I think we're currently, more or less ignoring it.
It will fail, yeah. So you have to remove the vendor.
Okay, so then the step would be to remove all the rendering and then
yeah, if you have that on repository already, yes, you have to drop it so that recipe tool can handle that.
Okay.
Yeah.
Further questions? No?
Yeah. Then thank you for your attention.
Thanks.
Mic test, mic test. Hello, mic test. It's good. Thank you. All right. Good morning and welcome to my session. Thanks for joining my session. Today we're going to talk about how to build a heterogeneous system using Yocto project. Myself is Sandeep Gundlupet Raju. I work for AMD. So currently I'm working as a Yocto project software architect at AMD, formerly Xilinx. So I'm using Linux since 2006 when I was a college graduate, and I'm using Open Embedded since 2010. Currently, I'm an active contributor to Yocto project, which includes a lot of Yocto meta layers, such as like Pocky, AMD Xilinx meta layers, meta ROS, meta virtualization, meta Jupyter, Open Embedded, U-Boot, Linux, and Lopper. Currently, I'm the co-maintainer of meta Jupyter and AMD Xilinx Yocto meta layers. You can email me at my email address and connect me at LinkedIn. All right, so we're going to talk about what is an heterogeneous system, what is like a system device tree, and how we're going to generate using system device tree, generate Yocto project configuration, and using those configuration, how to build multi-config build system using Yocto project, and what we deliver in the Scarth Gap release. So basically, Yocto project can build a variety of like targets such as like Linux, FreeRTOS, Zephyr, bare metal, etc. Using a multi-config, one can target a combination of these environment into a one single heterogeneous build configuration. And today we're going to talk about how to configure a multi-configure build with the integrated binary components for heterogeneous system using system device tree processed through a tool called Lopper to generate the multi-configuration machine configuration files, and the resulting configuration files can be used to build Yocto project and package these heterogeneous build images to an image that is not limited to like Linux kernel, dynamic firmwares, Zen, OpenAM, FreeRTOS, bare metal, etc. using Yocto project. So basically, the modern system on chip is very convoluted, and design requires like heterogeneous systems such as an application processor unit and real-time processor unit, a programmable logic, etc. on a single SoC. So for these kind of heterogeneous system, we need a separate build configuration for multiple CPU clusters such as like A72s, R5s, Microblaze to run different operating specific environment such as like OS, a bare metal, or an RTOS in parallel on a single system on chip. And using this for any software requires different hardware configurations, such as you need a like memory allocation, address mapping, register mapping for each different CPU cores. Current device tree bindings are little complex with the sharing with standard shared memory configuration for an asymmetric multiprocessing system, which is today it is done in a very ad hoc way. So what is an heterogeneous system? Basically, an heterogeneous system is a system with multiple CPUs or a cluster of CPUs that uses like shared memory and devices to be allocated. For example, a single SoC can contain like an application processor unit and real-time processor unit, programmable logic, which means like Microblaze, AI engine, DSP engine, and each CPUs can run and execute at different operating environment independently. For example, I can run an Linux on APU and a FreeRTOS on RPU, such kind of things. So in order to build an heterogeneous system with the multi-config, it requires like three components. One is the subsystems, domains, and protection. So what is a subsystem? Subsystem is nothing but a group of hardware resources. And for example, I can have like a cluster of APUs or RPUs or microblaze or a DSP engine, AI engine, or a video codec unit or a processing systems. So each subsystem can contain 0 or like more than 1 domains. And each subsystem can have like multiple CPU cluster. A subsystem can be a domain with only 1 core or like CPU clusters. Basically, this subsystem information is used by the firmware devices, firmware components, and typically this is defined by the hardware architect. What is domains here? So domains is nothing but a hardware resources, group of hardware resources used by software, for example, like bare metal, an operating system, or an hypervisor. Only one CPU or a cluster of CPUs are allowed in case of domains. So basically, in case of domains, it uses like one address space. A domain can contain another domain, like a nested domain. For example, hypervisor, I can run an Zen DOM0 on a APU and then DOM-U on an RPU. So these domain information is used by the build time or the runtime for each operating environment or like hypervisor. Typically, these domains are defined by the software architect. So next comes to like protection. So basically, protection is nothing but to protect your subsystem or a domain. So this is nothing but like a firewall to your processors. And typically, these protection is defined by your hardware registers. For example, we can add a trust zone for an APU or any hardware protection for memory or protection units for peripherals, etc. And basically, this protection can be defined by either a software or the hardware. And also, this protections are information is used by the firmware components. Let's talk about the system device tree. So before going to the system device tree, let's talk about like the device tree basics. So what is meant by device tree? Device tree is a concept which describes the system hardware. Basically, it is a data structure which describes the physical device such as a bus, a CPU, memory, peripheral devices, etc. So where are these device trees are used today? Today, device trees are used in like U-boot, Linux, Zen hypervisors, and Zephyr RTOS. So basically, a boot program loads the device tree into a client memory, and what it does is it passes a pointer to the device tree to the client, then it will be loaded by the kernel or any operating specific environment. So basically, this traditional device trees will describe only one address space. It doesn't describe like multiple address spaces. So in case of a heterogeneous system, it requires like multiple device trees in order to run each operating environment. For example, I need a one device tree for APU, one device tree for RPU, one device tree for microblaze or AI engine, etc. Next is the system device tree. So system device tree is an open device tree that defines the complete heterogeneous hardwares, such as it includes domains. Domains is nothing but a set of nodes defined for each address spaces. And it also includes like resource groups. Resource group is nothing but shared nodes grouped together, like sharing some address spaces. So system device tree also describes the multiple CPU cluster, and it also their corresponding view of address spaces. So we can't directly use system device tree to any operating environment such as like Linux or Zephyr or Zen. In order to convert to a system device tree to a standard device tree, we use an open source tool called Lopper, which transforms the device tree. Basically, it prunes a system device tree into an operating specific environment to a standard device tree. So using Lopper tool, user can merge or remove nodes and resolve any of the addressing spaces here. So there is a talk from my colleagues Stefano and Bruce Ashfield. I've added the slides here, reference. For more details, you guys can refer to those slides on system device tree. So basically, this is the snapshot of a system device tree. So when you have like more number of CPU cores, like APUs, CPU, HARPHIs, and microblazes, I've taken a snapshot of just one single core here. And this is the syntax of the system device tree, how it looks like. And we use a Lopper tool. And Lopper tool has basically like three components. One is the lops, which is the Lopper operation. And another one is the Lopper assist modules. And the third one is the vendor libraries. So I haven't listed vendor libraries here, but basically it contains like libraries for the libftd and the pyftd. So the one which is let's come to the lops. Lops has like different lops DTS files. Basically what it does is it takes the system device tree and transform into like different processing standard device tree for like APU specific, RPU specific, etc. So the one which is highlighted in the green is like very specific to like a metaxilinx layer. Basically, it has like three lops device tree. One is the machine name device tree, the CPU ID device trees, and the microblaze. So what does the machine name device tree does is basically it takes a system device tree and it generates the machine name, and that machine name is associated with the compatible string of your device tree. And next one is the CPU IDs. Basically this lops file, what it does is it transforms all the number of cores associated with your system device tree, and it generates the each ID for the each core. And next one is the microblaze, which is very specific to like Xilinx microblazes. So basically it identifies the microblaze nodes in the system device tree, and it will transform to the standard microblaze device trees. And next is the lops assist modules. Basically the lops assist module mainly it contains like generating the domain DTS and the bare metal and any additional like third party vendor assist files. So the generate domain DTS, what it does is it has a module called like Linux DT. Basically you take the system device tree and use this lops assist modules, and you generate the Linux device tree, standard Linux device tree, and you can specify for which core you are targeting the Linux device tree. So for example, if a processor has like multiple APUs like 0 to 3, so I can target for like 0, 1, or 2, or 3. By default, it will be targeted to like a 0. And same thing with the driver list, and this module assist is very much specific to like AMD Xilinx drivers. Basically, this target will it will generate drivers, bare metal drivers for like APUs, RPUs, and microblaze. Same thing we can target for each specific CPU cores. And the next one is the overlay DT, which has like it generates the programmable logic overlays for the PL. It can be a like full design PL or a DFX based design programmable logic. So once you take the system device tree and use the Lopper tool and transform to a standard device tree, so this is how it looks with the standard device tree. So here I have to like trim down to adjust with the slides. So this is the standard device tree format. Basically, it's a Linux DT format for the APU, and this is the bare metal DT format for RPU, and this is a bare metal DT format for a microblaze. Let's talk about Yocto project. So I'm not going to go deep dive into Yocto project. There are like several tutorials, nice documentation provided by Yocto project community. You guys can go through that, but I will just quickly give an overview of Yocto project. So Yocto project is an open source collaboration project that helps the developer to create a custom Linux-based system for an embedded products and any other targets regardless of hardware architecture. Basically, this provides a flexible set of like tools and environments used to create like build Linux, bare metal, Zephyr, RTOS, hypervisors images for embedded devices. And this is the Yocto project architecture diagram from the snapshot from the Yocto project mega manual. All right, let's talk about the Yocto project overview. So already like Salva already talked about in the previous session on some of the terminologies used in Yocto project. The first one is the bitbake. Bitbake is nothing but a build engine of Open Embedded. Basically, it has the task executors and the schedulers. Next one is the layers. Layers is nothing but a collection of metadata. Basically, it includes the configuration files, recipes, custom scripts, and it can be organized into a files and directory structure. What is recipe? Recipe is nothing but a metadata file which contains a list of tasks on how to build a particular software packages. Next one is the configuration file. The configuration file contains the global build system settings in the form of like simple variable assignments. And for example, you define a variable in a recipe and you can override those variables from the configuration files. Next is the machine. So machine describes basically the hardware configuration files based on your processor or the SOC tuning files, for example, ARM v5, v6, v7, etc. So next one is the user configuration. So basically in user configuration, you have like two components here. So one is the local.conf, where user can override what and define what is required for the build system. And basically it has like minimal set it requires is the BB number of threads. So what is BB number of threads is the maximum number of threads that are assigned for the bitbake to execute like simultaneously. Next one is the parallel make. So parallel make is nothing but the extra option you pass to the make command during the do compile task in order to specify like parallel compilation to your local build host. Basically it is like list of additional features you include there. Next one is the distro is the list of additional features you include in the image. And the other one is the extra image feature. So the extra image features, like for example, you want to have enable some debug tweaks or generate some SDKs, such kind of things you can add it to the image. The next component is the bblayers.conf. So if you have like once you source Yocto project Pocky layers, you get like you get like minimal layers. In order to build an heterogeneous system, there are like number of dependency layers. You can add those dependency layers to this bblayers.conf, and you can build a system. And basically, this is the tree structure of your build configurations. So it has like a conf directory, a bblayers.conf, and local.conf. So next one, how the regular default build configuration is different from the multi-config build configuration. In case of build configuration, you will not have something called as like multi-config directories. So you can use a single bitbake command to build like multiple images or like package different targets, where each image or the package requires like different configurations, like we call as like multi-config, and we usually go with MC as a like a short terminology. And basically, so for example, if you look at the multi-config directory, we have like 2 configuration files which is specific to 2 different architectures. One is like ARM and one is for x86. And if you want to target a build system with like multi-config, then you had like BB multi-config variable, and using those variable you specify each target operating environment and with spaces. You can specify n number of target operating environment, and which is supported by Yocto project. And this is the basic difference between default bitbake build configuration and the multi-config configurations. So for example, if you want to build an image, you specify like bitbake target command, for example bitbake core image minimal. In the same way, how you do it in the multi-config is like you use like bitbake multi-config from target, and again multi-config name with the target. So basically it will be like bitbake MC colon with the architecture like x86 and the image name like core image minimal, and you can specify it similarly for like ARM or MIPS, etc. And also, if you look at the major difference for the multi-config build dependency, for example, if you have a bitbake task, basically you have a task like do compile with some dependencies, such kind of things, right? Do image with the dependencies with core image minimal with do root fs. Similarly, in case of multi-config, so you will have something called as like multi-config from multi-config and to multi-config, and the recipe name and the task on which it depends on. And usually by default, even if you leave blank, so that will be treated as like from multi-config, and we have to specify the to multi-config as the mandatory thing. On the left side, if you look at like a bitbake target, like bitbake core image minimal, and you can use the same thing using multi-config as like bitbake multi-config default target. Basically, the default target points to your default multi-config settings. Next, we're going to talk about how to generate Yocto project configuration using system device tree. So in order to generate the system device tree, you need to run, you need to have a prerequisites here is like you need to download and install the AMD Vivado hardware tools, and using these hardware tools, you need to generate a design, and then the output of the hardware design is nothing but your XSA. And using that XSA, we have something called as system device tree generator. So you can use that XSA as the input, and you run through set of commands using the system device tree generator, and that will generate a system device tree files for your hardware specific. And the next thing is like you need to clone like Pocky, Meta Open Embedded, Meta Virtualization, and Meta Xilinx layers in order to build heterogeneous system. So since the Lopper tool is in Meta Virtualization, that's the reason we are depending on like Meta Virtualization. Yeah. And the next thing is like initialize and build the set up the build environment using by sourcing the OE init build script. And you can add later on, once you source the script, basically it contains the BB layers contains the Pocky and Meta Pocky layer and Meta Pocky BSP. So optionally, you can remove the Meta Pocky BSP layer, and then you need to include like Meta Open Embedded, Meta Virtualization, Meta Xilinx layers using like bitbake layers, add layer commands. So these are the like simple instructions. How do you clone the repos and initialize the Pockinit script and add all the dependency layers. So in case of when you clone the meta-Xilinx, we recommend to use like recursive submodules here. So in order to clone other submodule repositories. Next is once you have the initial setup, we need to use Lopper tool and how the Lopper tool does the step-by-step transformation. Basically, Lopper tool is part of the device tree org. You need to clone the Lopper tool. If you are building some bare metal components for AMD Xilinx chipsets, then you need to download the embedded software repository from the AMD Xilinx GitHub. And once you clone the Lopper tool, so you need to export the Lopper DTC flags. Basically, it is nothing similar to like how you had the DTC flags, device tree compiler flags for an overlay. And once you source the device tree flags, we're gonna transform the device tree to the system device tree to like standard operating environment specific device trees such as like Linux, bare metal, FreeRTOS. And also for any bare metal, we need to generate like additional configuration files like .h, and also the bare metal should include like bare metal drivers and similar thing, same thing as for the programmable logic also. We need to have the device tree as well as the configurations. All right, here is steps how you transform from a system device tree to a device tree. So basically, you clone the Lopper repo and you clone the embedded software repo, and these are the minimal like variables we use in the system device tree. And each multi-configuration or the Linux configuration, basically it uses like config dt file. Basically, what is the dt file is required for each operating specific environment. And these are like unique variables, not it's like common variables, but it is associated with each multi-config machine files. All right, so first thing is you need to have a machine name. How do you generate a machine name from the system device tree? Using Lopper tool, once you export the like Lopper DT flags, so you need to use a lops machine DTS file, and you need to target the system DT file. Basically, the system DT file is your output of your system device tree generator file. And how do I get the number of like CPU cores configurations? So for that, same thing, we use the lops, but here in this case, we use like a lops Xilinx ID CPUs, and it will scan through the system device tree, and it will generate a number of CPU cores, and it will generate the nodes for and node labels for the CPU cores. Next is the overlays, like all the AMD Xilinx FPGAs on the SOCs. It has like PL programmable logic, and each programmable logic you can load at the boot time or you can load at the runtime. So when you load the programmable logic at the runtime, you use something called as like PL overlays, which can be loaded at running Linux. So if you are using the overlays, then we use the lops assist called like XLNX overlay DT, and we specify what kind of the design we are using, whether it's like a full PDI or the bitstream loading, or you use like a DFX design based bitstream or the PDI. And same syntax we use, similar syntax we use for the without overlays. You for like a Linux configuration, we use something called as like generate domain DTS, and we specify which core you are targeting to generate the Linux DT here. So once you run through the Lopper commands for the Linux configuration, this is the output of your machine configuration file. So basically it contains all the multi-configs, a tune files, and a config DT file, a system DT file which is required only if you are generating some of the bare metal components. And also it includes some of the libraries and the features, and we have something called as like depends, right, in Bitwig. And similarly, we have something called as MC depends, which is like multi-config depends. And if my Linux configuration is depending on any of the multi-configs we define here. Similarly to the like temp_dir in your Bitwig, so we also use MC temp_dir. So basically, so you take the build artifacts, and you can't combine all the build artifacts in one single temp directory. You need to like segregate into like different buckets. So for example, have a separate temp directory for like Linux configuration, bare metal, FreeRTOS, etc. Apart from that, the machine configuration for Linux can include like U-boot configuration, like def configs and Linux def configs, and any additional machine features or extra image features. I'm just taking the snapshot of like what is the major thing we use for the multi-config in case of Linux configurations. Okay, next we're going to talk about how do you generate the system device, standard device tree using system device tree for a bare metal or FreeRTOS. Using Lopper tool, we use something called as the LOPS with the processor-specific MUX LOPS DTS, and using those DTS, we generate the bare metal configuration for a APU or an RPU. But in this case, you need to use which processor you are trying to target here. And the output of the, okay. Next one is the how to generate the driver configurations for like bare metal or like FreeRTOS. So similar to like DTS, we, in addition to the DTS, instead of like we are using the different LOPS assist, here we call like a bare metal driver list, and we specify the target processor core. And we also, in addition to that, we additionally pass the argument to the cloned embedded software repositories. So that will generate the machine configuration files for the bare metal drivers. For example, for each bare metal drivers, it is considered as a machine feature, and it will be generated in the bare metal configuration file. So this is the sample output. Basically, the bare metal config has like two files, which is the features.conf. Basically, it will come with the prefix with like Cortex R5 0 bare metal dash features.conf. And that features.conf contains a list of all the bare metals peripherals enabled and the drivers enabled for your specific design. And the next one is something called as like a driver list config CMake. It is the same list of which is defined in the features.conf, but it will be in the format of like CMake, because the embedded software component, bare metal components, doesn't understand what is like how it is written in the Yocto machine configuration file. Instead, it understands how it is generated with the CMake. So next one is the YAML file. Basically, YAML file is nothing but what all the drivers you have enabled in your IP, and it will specify all those list all those drivers in the YAML format. And next one is the libzil conf. Basically, it is a metadata consumed for the libzil compilation in the Yocto project multi-config builds. For example, each driver should be linked with a specific library. So and we define it as in the package config, and user can enable and disable those package config depending on what drivers they have enabled. All right, so this is the output of the bare metal configuration file. Basically, it contains the config dt file, which is pointing to the bare metal DTSI file. And here we use something called embedded software machine name. So the machine name will be specific to the bare metal configuration. And it has like default tune. It will be setting to your R5 or Microblaze, etc. And also it depends on the what kind of distro you are using for your bare metal configuration. This is the basic syntax of the bare metal or the FreeRTOS configuration. All right, so for a Microblaze configuration, we use the Lopper tool and we transform to a Microblaze configuration. Here what we do is we specify, instead of specifying to an APU or a RPU processor, we specify with the Microblaze processor, and same thing, we generate the driver list for the Microblaze, and we use this PMC as a like platform management controller, which contains both like a PSM and the PLM, a platform loader and the system manager. This is for the similarly, we use Microblaze for the PSM. Once you generate the configuration files, we generate something called as tune files for Microblaze. So Microblaze, we need to specify what kind of tune files you're going to use, and this is the sample output of the PSM and the PMC Microblaze configuration files. And also you can set additional like target flags in case of Microblaze. So now we have like a DTS configuration, etc. So we generate something called as like additional parameters, what is enabled in your design. So basically we convert those, transform those params, and we put it in a like a header file, and that header file will have that like register address and offset, etc. And that will be named as like xparameters.h. And for each APU, RPU, and Microblaze bare metal or FreeRTOS configuration, we generate these params. And this is required for the bare metal or the FreeRTOS builds, multi-config builds. Okay, so now we walk through all the like step-by-step transformation from Lopper using like system device tree to a standard device tree. And what we do is user can use a step-by-step process transformation, or we have something called as an automated script, which basically takes this input as the system device tree, and it will generate the multi-config and the DTS and the machine configuration file. And this script we call as like a DT processor script, and it is available in the Metaxilinx Yocto project layers. So in order to, this DT processor script basically depends on Lopper tool. So in order to transform a system device tree to a standard device tree, we need to build an SDK using the Lopper first. So we have a setup SDK target recipe, which takes the Lopper and it generates the sysroot, and once the SDK is generated, so we're gonna install that SDK, and then we run through the DT processor.sh script, which generates the DTS machine configuration files and the multi-config. And later on, we can use this multi-config configuration files and DT files, and you can build the target image for like multi-configuration. And once the images are generated, you can emulate or run on the hardware using emulate using QEMU or run on the hardware. So this is the basic steps in order to set up the SDK, and once you set up the SDK, you run through the script, and that script will basically transforms all the system device to operating standard specific environment device trees, and you can use those configuration files, and you can specify the target image like machine is equal to so and so, and then you can build the target images with the core image minimal. So this is the snapshot of like how the content of like the multi-config looks like. Basically, it includes a DTS file, DTS directory, and a machine directory. And machine includes like a machine configuration file. You can see at the last, you can see that is the machine we're gonna use to build it like as a default image. And you have the multi-configuration files directory, which contains all the multi-config for like bare metal, FreeRTOS, and the microblaze configuration file. So alternatively, if you are not using like the DT processor script, we have a tool called like generate machine configuration files. And this is something we implemented recently. And what it does is it takes the input as the system device tree files, and it generates the DTS machine configuration files and the multi-configs. So this tool is nothing but a standalone tool, and when you clone meta-Xilinx layers using the recursive submodules, this tool also will be cloned, and you can source this tool and run through the system device tree, and you can generate all the images. And there is a talk on the Gen Machine Conf in the Yocto project Summit 23.11. So you can see the video recording and the slides if you want more details on the Gen Machine Conf. And this is basically the syntax for using Gen Machine Conf, how you generate the transform the system device tree to standard operating device tree and the machine configuration files. All right, what next in ScartGap? So in ScartGap, we're gonna deprecate dtprocessor.sh support from meta-Xilinx, and we enforce like users start using the Gen Machine Conf tool, and basically this is written completely in Python. So it is like more modular, and which already, when you run through the Gen Machine Conf, you don't need to run all the setup SDK, which you build the Lopper native packages, all those things. And with the Gen Machine Conf, usually we don't need to detect the machine type. Basically, if your machine type is like a ZincMP or like Versal or any other architecture, it will be dynamically detected from the system device tree. And in ScartGap, we are adding a bitbake class which supports like packaging and deploying like multi-config binaries or the help files to the Linux root FS. One such use case is the OpenAMP, which requires to run some RPU firmware packages, so on running Linux in order to run OpenAMPs. And also we are targeting to add Zinc 7000 and microblaze system device tree and Lopper support in ScartGap, which is targeted for like fall 2024. Cool. That's it. If you have any questions, I'm happy to answer.
Hello. So I'm fairly new to Yocto and whatnot. I've used FreeRTOS fairly extensively, and I'm really interested in this idea of having the device tree for deploying FreeRTOS. How does that integrate with the build tool itself? I know that you mentioned that it's using the CMake script, earlier on, but like, is that applied as a layer or something? How's that work?
So it is applied as a layers. So basically, it is all, when you clone the embedded software repo from the Xilinx repositories, so it has all the FreeRTOS components and the bare metal components. That's where we use all the system device tree approach, and we use the YAML infrastructure, YAML files in order to detect all the processor type and what kind of drivers you are including in the FreeRTOS or the bare metal, and we generate based on the configuration, we generate all the drivers.
And so that configuration is translated into like the FreeRTOS config, whatnot, where you're deciding which kernel features get turned on and such?
Kernel features, I'm not sure on that one. I'm not a FreeRTOS expert. That is something I can figure it out and I can let you know.
All right, thank you so much.
Thank you.
Is AMD committing to support ScarthGap through its entire LTS, or just
that is something new. We are till today we are very much tied with hardware releases. That is something we are trying to shift our gears from hardware to software. So if you look at our previous releases, like kernel is LTS, U-Boot is LTS, but not Yocto project, right? So that is something we are moving our strategy from hardware specific release to LTS specific release. So we're gonna have Yocto project LTS. That's the reason why we are doing all this system device tree. Everything is we wanted to basically decouple from the hardware tools, and even if you generate the anything specific to your IP, but everything will be in the form of system device tree, and we use the system device tree as an input to the system multi-config builds.
So the updates that you guys have traditionally done, are those going to be specifically targeted at ScarthGap throughout the entire cycle? Okay.
Hi, my question is related to the first part of your presentation where you talked about multi-core systems. In a Xilinx single core setup with a single core ARM plus FPGA, what would be the best usage of replacing the single core with a dual core? What would be the best usage of the second core in regard to boot time optimization and performance in general?
I'm really not sure. So yeah, I'm not sure to answer your question. So with the boot time optimization, if you replace
performance in general,
yeah, I'm not sure on that one. So if you just replace a single core with a dual core, right?
What could the second core be used for?
So second core, you can use it for a bare metal or like an AMP, right? Open AMP is like a symmetric multiprocessor. You can communicate from one core to another core, right? So you have like two APUs and you can talk to each other using an AMP concept.
And what would be the effort of this, implementing this communication?
So already we support OpenAMP. So OpenAMP is one more open source organization. So with the AMP, you can communicate from one processor core to another processor core. So you can run some like shared memory and resource utilization, all that can be done through AMP.
Is that already available in Metac Xilinx or some other layer?
AMP is even, I think it is, even Linaro is part of our AMP project. I know like even you can run AMP on different SOCs, not just like Xilinx specific.
Okay, thanks.
But I'm not sure on the performance numbers when you replace it or when you communicate between the two.
Hey, Sandeep. So for bare metal and FreeRTOS applications, the expectation is that they're going to come in from the embedded software repo, right?
Yes.
So let's say I have an application. I would clone the embedded software repo first, perhaps grab something that exists already, and then base it off on that. Because it seems like it's all wired through that repo. There's no way to like use a separate repo with the application.
You can use a separate repo. That is something we are trying to decouple in 24.2. You can what you can do is I can have my own bare metal application, which is not tied to embedded software, right? Generating all the X parameters, .s, all those things. So something we are trying to achieve in 24.2 release timeframe. So user can bring in their own bare metal and try to compile with the multi-configs. So for example, if you look at the Kriya products, we use something called as image selectors. Basically, it does AB mechanism update boot firmware components. So that we are trying to decouple first, so that right now it is tightly coupled with the embedded software repo. We are trying to decouple. Once we decouple that, so we can bring in any bare metal applications, and you can compile using the without depending on the embedded software repo. That's on our radar.
Thanks.
This led to your question as well. Yeah, exactly. So as a follow-up to that one as well, is the idea, I'm really fascinated with the idea of using device tree for things like, I noticed the memory regions and stuff, FreeRTOS is having its support for protected memory regions, MPUs, things like that. Is sort of the user intent of this system that we'll have access to that device tree,
Yes.
as part of the build scripts, and then we basically read that device tree in order to do
Correct.
things like.
So user will have access to those device tree, and even if you look at Zephyr, that is something we haven't evaluated. Zephyr uses the device tree, right? So we wanted to have the same concept, and even if some customers want to replace an FreeRTOS with a Zephyr, they can do it. So, and Yocto already supports with the Meta Zephyr layer, so it should be pretty much easy and straightforward.
Some really fascinating stuff. Thank you.
Yeah, cool.
Hello. Just a small question. The DT process script, this approach you demonstrated, it is valid for which version of Vivado and
So right now,
Netax
the DT processor script is independent of the Vivado version, but
starting.
you can use it for 23.1 and 23.2 Vivado tools.
Okay, thank you.
Sorry, it looks like we are over time. Cool, thanks.
Yeah, thanks for the.
Yeah.
Okay.
Yeah, sorry, go ahead.
A short question. Thanks for your talk, first of all. I did a similar concept for the other SoC FPGA vendor. And that means your concept works only for AMD, mine's for the other one. Is there any intention to set up in standard? Because it's not only for SoC FPGAs, because we have seen more and more of these complex SoCs arising.
So all the system device tree and Lopper, it's open source. It's not very much tied to Xilinx specific. And in order to do some specific vendor specific components or libraries, Lopper has that vendor libraries, right? Or the assist files. You can bring in your vendor stuff and you can process through.
Okay, thanks you.
Thank you. Or cool. Thank you. Looks like I'm over time here.
Into Lopper.
Hey, Natalie. Cool. All right. Oh.
get you another one if you want to.
Yeah, if you can, please. Yeah, that'd be great. Thanks.
Okay. No. Okay. You can
good?
start. Yeah. Good. Howdy, everyone. Thanks for
Morning,
waiting.
afternoon, evening. It's just afternoon, it's fine. Fashionably late as always. So thank you very much for joining us. We're going to cover, obviously, the Yocto project. And if you've been involved in the Yocto project or aware, we've had a 5-year plan. So now what with the 5-year plan? So let's wind back the clock and go to the very beginning. The 5-year plan was developed by the members of the Yocto project. The question was, how should the Yocto project look like in 5 years? Oh, let's come up with a 5-year plan then. And so the focus, was very much how can we ensure that the project has legs, has longevity, is sustainable? How can we ensure that it's as secure as it can be? How do we make sure that we have a healthy community around the project and keep that technology ticking along and getting all the new stuff in as possible? 3 key aspects to it. As with many open source projects that have been around for a while, there is a maintainer gap aspect to things. So one of the focus areas was how do we minimize single point of failure with our current maintainers? How do we ensure that we have a healthy pipeline of people participating in the project, contributing to the project, feeding into that whole sustainability aspect of the project, and looking at growing the membership of the project. We've done reasonably well. There's been plenty of ups, a couple of downs, but for the most part, we want to grow the project to be able to be self-sustaining. So it all kind of feeds together. And so moving forward, we identified the gaps. We went out to the community, got some quotes, and then identified, right, we need money.
Shocker.
I tried going out with a cap in hand. It didn't work so well. Tried a bit of dancing. Again, not so well. And so we decided that we were going to target membership growth and kind of hive off new membership in 2023 to fund our 5-year plan.
Okay, so thanks, Andy, for giving us an overview of how we got here. From the 5-year plan conversations with members in the community, we focused on 9 areas of improvement for the first part of the 5-year plan. So it's been about a year now since we have started this forward momentum. So we'd like to kind of review what those areas of focus are and then give an update on where we are with all of those. So these are the 9 areas of focus that we were talking about. And as Andy was mentioning about the alternative funding streams, right? We were actually approached by the Sovereign Tech Fund. And this was after we started developing our 5-year plan. And they identified the Yocto project as a critical open source project. And they wanted to help invest in some of the tooling to guarantee security and sustainability for the future. And this is because of all of the reasons that most likely you all have selected to use the Yocto project, right? It's flexibility, regardless of architecture, and it's used across almost every industry vertical in safety critical and non-safety critical applications. So there was a big interest in trying to invest so that we could see forward growth, work on security, and things like that. So when we were awarded the investment from the Sovereign Tech Fund, we were able to actually supply funding for 8 out of the 9 original areas of focus. And so we sent out the world's largest RFQ, and away we went in trying to find the right experts in the industry to help us be able to work on all of these different tools. So patch test was one of them. If you were in the mini summit yesterday, you heard a great update from Bay Libre on all of the work that they did with patch test. So I won't go into it too deeply, but long story short, patchwork needed to get updated. The updates broke patch test and therefore kind of left it broken for a pretty long time. And when you work off email patch submission, this is not great. So big thank you to Bay Libre for coming in and supporting this work. And now it's no longer broken. Trevor's presentation will be on our YouTube, and he goes really far in depth on all of the specific aspects. So I would highly encourage you to visit the Yocto project YouTube in about a week and check out his presentation. One of the other areas was Toaster. In my mind, I visualize it as this really adorable toaster, but I think a lot of people who previously used it would say, no, it's not so cute. It really, really, really needed some tending to. It's a web-based UI, kind of a GUI, and it really needed some work. So Savoy Fair Linux came in and did a lot of updates to Toaster, as you can see here, enabling it to work with the current code base. It's kind of a baseline, right? But it really needed to be done. And so Mohammed Raza from Savoy Fair Linux gave a presentation on Toaster specifically yesterday, including all of the updates that are included in ScarthGap coming out later this month. So again, I would encourage you to go out and watch Mohammed's presentation on the specifics for Toaster. So core workflow improvements, we had the help with Linutronics. There's just some words. And so the goals with this were to reduce frustration, reduce build times, and just simplify the core workflow as a whole. That has been completed and should be out in ScarthGap later this month. Again, project tooling, Bay Libre took this one for us as well, and it was covered in the presentation yesterday. But a lot of these tools to automate common developer tasks just really, really needed to be updated. The maintainers for those tools had moved on to something else or started working on another tool. And while these tools were helpful, they weren't as helpful as they could be with the newer versions of Yocto. So DevTool got improved support, Recipe Tool got improved support, and all of the backlogged features and bugs were cleared, which is super awesome. So thank you to Bay Libre for making that possible. All right, so another one was Meta Open Embedded, and this was headed up by Consulco Group. And essentially, we wanted to improve testing and formalize processes. So CVE checking got added, patch test checks can be enabled per layer, and we instituted a deprecation policy for layers and reproducibility reports, which will be super important once the CRA becomes an official thing. So thank you to Consulco for taking that work on. Well, security, you can tell, was a point of focus because the things that were done exceeded the, the bucket container that we had for it on the right-hand side. But security was one of the main focuses of Sovereign Tech Fund's initiative in investing in Yocto project. They really wanted to see a dedicated team for security, formalized processes, and as we know in the last few versions of Yocto project, SBOM generation has been included, but it was not automatically enabled. You had to manually enable it. Now it will be automatically enabled, so all of your legal and compliance teams can rejoice in your beautiful SBOM manifestation created automatically for you. And as part of this work, SPDX 3.0 was POC'd, so once that's ready to go, we should have that available and running as well.
Yeah, and huge thanks to Marta for a lot of the security work.
Absolutely. And we're getting to the end here, so we've got the VS Code IDE. Savoir Faire took this one as well. We debuted this at Embedded World last week, if you were there, or if you heard about it or saw something on LinkedIn. This is a plugin now, directly available, super simple, super easy to run, and it connects to a variety of IDEs. Mohammed, the same person who worked on Toaster, also took this body of work as well, and he went into explicit detail on how to actually run this in his presentation yesterday. They're also at the Yocto project booth in the sponsor showcase. Mohammed's there and is happy to answer any questions. There's a QR code that'll take you directly to the documentation for that. Yeah, for the cool kids, as they say. We've got the binary distro that Bootlin's taking on, and this one is still a work in progress. It was a huge body of work to take on, so big thank you to Bootlin for being able to push this out, and we do anticipate it in the next few months being available. And then lastly, we've got Layer Setup, also taken on by Linutronics. And this is our last work in progress. So as you can see, just over the last year, there's just been an incredible amount of work taken on by both the leadership team at Yocto Project, the developers in the community, and all of the consultancies assisting us with this RFQ. So thank you to everyone, because it would not be possible without your feedback or your contribution.
Right, so that's kind of 5-year plan side of things. What next, right? So one of the things that we want to see moving forward is how Yocto project can actually expand what it can do, right? There are multiple areas where we work really, really well. Some areas, not so well. So how can we expand the capabilities of what the Yocto project can do? One of those is from the OS perspective. Why do we just do Linux, right? Linux is great, don't get me wrong. What about others, Lots of cute OSs out there. FreeBSD is one. OpenBSD, NetBSD, whatever, right? Yocto project can build for whatever you want it to fit. But sometimes you kind of need to actually choose the right software stack to meet that. And FreeBSD has got some advantages. There are some companies out there that are very GPL averse, right? Regardless whether it's GPL v2 or v3. They just do not like those 3 letters together. So FreeBSD is an alternative platform that would allow them to continue using their current workflow, but not have to worry about some of those license issues. We want more architecture support, right? There's lots of up-and-coming pieces of hardware. Now, don't get me wrong, I work for ARM, and I think we're the best architecture. However, with my chairmanship hat on, there's lots of space in the ecosystem. So we'd love to have RISC-V supported. We'd love to have OpenPower supported. We were hoping to have had RISC-V support for ScarthGap. However, not enough members stood up to help fund that work. Adding architecture support does increase cost to the project substantially, both from manpower, system from an auto builder perspective, etc. So it does require some funding. So hopefully we can actually engage more of the membership to participate in that. It is 2024 after all. Surely the Yocto project should be doing something around AI. Everyone else is, so why aren't we? So we need to look at what can be done from an AI perspective. Is it that Yocto is what's used to build the reference platforms for a number of AI solutions, whether it be leveraging things like UXL from an accelerator perspective, whether it's making sure that BSPs for platforms that have NPUs, GPUs, etc., work as well as possible. So the areas that we need to look at. And we kind of want, actually, we need more people to step up and take on chunks of maintainership. Richard Purdy, our current project architect, has a huge amount on his shoulders, right? And a big concern to the community is the bus factor, right? We want to alleviate that. We want to make sure that the load is spread. So if you are so inclined, please do step up. You will be showered with love and adoration. I can't promise any greenbacks or whatever your preferred monetary item is. However, there's a lot of fun to be had. There's no pain, I promise-ish.
Well, and just to touch on this some more, I mean, when you look at, the tooling and the gap that we had to cover with this funding, right? I mean, this was from years of technical debt stacking up, essentially increasing developer frustration, which decreases the opportunity for contributorship and feature improvements because you're so worried that you've got to work on bugs and things that are more critical. So these tools are really important. The community tells us they're really important. We need someone to maintain them sooner than later so that we don't have that technical gap building up again. We've worked so hard to close that gap, and it would just be a shame to see all of that start piling back up. Everything's working now. Cleared backlogs. Let's keep it that way. That'd be amazing.
Yeah, I mean, and there's an initiative being kicked off to identify and clearly identify the specific roles within the leadership group to help alleviate some of the burden on the architects and the technical folk that are able to step up. So it will be a lot of fun, I promise. And it will, there's a lot of scope for growth. We would love to have some form of kind of internship if that's feasible at some point. There's lots of ideas that are kicking around of how can we grow the technical capability of the community and members at the same time. Because at the end of the day, we want to give back a little bit to our members as much as they give to us. So how can you get involved? What's the project going to look like in 10 years, 20 years, 50 years, right? More contributors are needed, right? Look at bugs. There's lots of low-hanging fruit that people can start getting their hands dirty on and get some practice on. Try a lot of the new tooling that we've just spent the last 12, 18 months developing for the community, right? Give us that feedback. Let us know what works, what doesn't work. If you find an area where you could improve it, have at it. And again, if your company's not a member of the Yocto project, tell them they should be, right? If you think actually we benefit a huge amount from this open source project, we need to give a little bit back. There's lots of ways that we can do it. Reach out to myself, Megan, or Randy Armour from the Linux Foundation, and we'll see what we can do. We would love to see more people participate, both from a monetary perspective, but crucially from a hands-on keyboard perspective.
Yes, so we've got a BOF happening Thursday, which I believe is tomorrow.
Yeah.
Perfect. Tomorrow in the afternoon, led by Philip Ballister, sitting in the back modestly. We had some really great discussion at the mini summit yesterday, especially around the aerospace and safety critical fireside chat that was going. So we're going to try and roll some of that discussion over into the BOF. But always come with your ideas, come with your opinions. It's usually a spicy session. I am filling in for Josef Holzmeier, so I have promised that I will bring chocolate. I will not throw as well as he does, but I will. Okay, perfect. Tim has taken this on, and I might try and smuggle in a bottle of whiskey, but you know, you didn't hear that recording. We'd love to have you tomorrow. Please come to the BOF. We'd love to hear your ideas and questions.
One correction, Smile did the meta of an embedded RFQ work.
Oh, thank you so much for that, Tim. Apologies to Smile. Thank you. Thank you. Okay, I think that's it.
Indeed, thank you. So we have some time for questions if there are any, or comments. I will take donations if you wish to put your hands in your pocket. Any questions? Yep. Shout, I'll repeat. Yeah, just for those that didn't quite hear and for the recording, Paul's saying that what we've just shown proves that far from these comments that the Yocto project's done, dusted, there's no growth, there's no need for anything else. Far from it, there is lots to do. We've done lots, and we've got a whole lot more to do on top of that. There's always room for growth, room for improvement, and with your help, we hope to be able to deliver on that growth and improvement for your benefit.
Yes, and as things like the CRA come up, there's different expectations coming from government and regulatory authorities with regards to software supply chain and things like that. So even if someone could say the project is complete, there's still changes in the regulatory, compliance, legal, et cetera, environments that we need to be adaptable for. I just met someone at Embedded World last week that told me that they were manually creating SBOMs because they couldn't get their client to upgrade from Sumo. So when I told him that it was automatically enabled and automatically generated and most likely error-free, he was ecstatic. And again, that provided him some talking points to put pressure on his client to try and move forward with some of these updates. So yeah. Many angles to work on that.
So going back to the, we're not done, right? There's a lot of new things that we as core developers would love to be doing. But as a consultant, I am being paid most of the time to uplift someone from some very, very ancient thing to some slightly newer thing. So that means all of my paid time and what is making Quinsulco profitable, right, is me working in the past. So anything that you're seeing me doing that's moving us forward, adding maturing support that let us do Python and Rust together, this type of stuff, right? So any one of the core developers will give you the exact same storyline. The only person that's actually paid to do the forward future work is Richard Purdy. Most of the rest of this work is not being funded. And so the industry has got to figure out a way to change so that the future is sustainable. We don't want to fall back into this technical debt situation that we had. We have to figure out a way that that's what we prioritize, so all of us continue to move into the future in the open, secure, safe, and profitable.
Thank you, Tim.
Well said. Any other questions or comments? Desires?
Thanks, Tim. Thank you.
Thank you for your contribution and for that presentation. I only was a little bit surprised that you haven't added BSP maintaining as one of your most concerns parts to the list as well.
Yeah. It's difficult to actually ensure BSPs are maintained by the respective vendors. We do our best to try and encourage them to ensure that they're updated, but it's really at their will. We do have Yocto compatible from a layer perspective, so you know that everything is maintained, is up to date, and it's all modern, etc. There has been discussions in the past around how do we do this from a BSP perspective? Is there some sort of gold star standard that we can do, or something along those lines? But it's not the easiest thing to manage and actually implement. Some people really don't care, right? Well, you've got some software, it works. Yeah, it worked for 5 minutes. Progress has moved on, and you're stuck in the past. And kind of to Tim's point, this is where a lot of the consultants come in and end up doing the heavy lifting of moving it or dragging it forward slightly, right? So I don't think Tim and others will have customers wanting to upgrade to ScarfGap for another 2 years or so, right? We've already moved on. So yeah, it's a valid comment, valid point, but it's a really difficult one to actually see through, but we will do our best. And as a community, we can all apply pressure to those vendors that are lacking somewhat, and hopefully they'll get the message and reach out for some help.
And on the vendor maintained layers as well, we did hear a lot of community feedback with specific frustration in some vendor layers that aren't being updated at what their clients are perceiving as the appropriate speed. And they come to us saying, why isn't this working? Can you help? And we can help direct and facilitate conversations to those vendors. And I found out that, for example, one of them is doing a complete overhaul. They're aware that that gap exists, but they haven't sent any messaging to the community at all that all these bugs are popping up and that they're actually paying attention to it, right? So I think some of it is also related to communication and just directing questions to the right place and putting that pressure on for change. Philip?
With respect to BSPs, the talk that was in this room before was from AMD, and they were saying very, very positive things about their BSPs. And I know myself and some others in the room have been long-suffering AMD customers. And the things we heard in the talk, I think, are a result of a number of us speaking to people at AMD about our concerns with their process. And they have made changes, and we're hearing really good things now.
Exactly. You never know that most likely if you're experiencing some sort of trouble, it's not just you. And putting those questions out to the community in whatever fashion, whether it's on a mailing list or an IRC, usually will give people the confidence to say, oh yeah, I've experienced that too. And with enough voices, then it's easy to put pressure. So yeah. Hey,
Bill. Not that you need a mic, but.
So I know it's not universally true, but in many cases, the best BSP is no BSP. And that's why we're doing generic ARM64. If the kernel, upstream kernel works, the def configs are all upstream or easily overwritable, that solves a lot of this problem. You still have the boot firmware to figure out, but one of the problems I always tell people when using the Yocto project is Yocto project gives you a lot of rope, and you can get yourself into trouble by having that rope. If what we really need to do is encourage the vendors to make things work upstream and eliminate many of the need for the vendor, the meta layers. And that's not going to solve all the problems. There's always going to be some need for the meta layers. But if you have the basic functionality that you need with just pure Pocky and the other supporting layers that aren't vendor layers, then you're going to be in a lot better position for maintenance. It's going to be a lot easier to move from Yocto project version to project version. So, the system ready, the ARM system ready standard and generic ARM64 hopefully can push at least the ARM part of this ecosystem towards that. And that's not going to be enough for everybody, but it's going to make things better when you are using a vendor layer.
Yeah, thanks, Bill. There are, as you say, going to be some cases where we're just not going to get away from it, whether it's because somebody's got some newfangled doohickey in their platform or what, but yeah, absolutely, just using the bare minimum is probably the best route.
In a perfect world, what kind of commitment would you like to see from contributors and maintainers? We hear a lot about people being overwhelmed, so it seems doubly scary, because do I want to get involved in something that everybody is kind of feeling this way?
So I think the biggest issue is from a reliability perspective. So if you're going to, and we can't expect everyone, but what we would like is have that reliability aspect of, okay, so you're doing patches and you're quite open and upfront that, look, I can only spend maybe an hour a week or something along those lines on doing whatever work you're doing. If you come along to like the bug triage and whatever else, and you say, okay, I'm going to tackle that bug, and I'll take that on, I'll own that bug, whatever. Having some form of communication back to the rest of the bug triage team of, okay, here's an update, or whatever else. What we tend to find quite often is that, unfortunately, people go radio silent, and we have no idea what's going on. We don't see any code. We don't see any emails. There's no IRC comms or anything like that, right? That's the big pain point, and that's what adds to a lot of the stress. And we don't hear anything, don't see anything. So Richard or the handful of people that we do have working very regularly on things end up taking it onto their plate and whatnot. We have at ARM, we have one person that is predominantly dedicated to upstream Yocto. We have a large team of people that work on Yocto internally, but externally facing, it's between 1 and 2 people. And I understand companies have to balance their business requirements, but just remember, without, if you're using Yocto in your product sets, etc., if there is no Yocto, you have no product, right? So it's trying to find that happy medium. And at the end of the day, if you're interested in participating, interested in contributing and doing some work, reach out, have a discussion of, look, what is it that you think is feasible for somebody that can do 1 hour a week or something along those lines, right? Let's have that conversation. We know where everyone stands then, and it's a nice, happy relationship rather than one fraught with, where the heck have you been? You said this and you've gone there, and everyone's blood starts to boil a little bit.
Yeah, and I do think the other issue that we've run into on this side of things is that people will say, oh yeah, I'm interested. Then we spend a lot of time onboarding someone. As you've mentioned, it's a little bit complex. So you spend all the onboarding time, and then that person decides, okay, I'm not interested in doing that anymore. And they just kind of fall off. So it's difficult to keep the time investment of onboarding when people start dropping off. However, we want to deal with the overwhelm, right? Just as much as we revamp the contributor guide and are doing a lot of work on documentation and trying to consolidate things and simplify steps and processes, et cetera, like, please, if people are saying they're overwhelmed with that, like, we would love to hear their feedback on if there are parts of the maintainership process that should be evaluated. Are we not siloing things properly? Is there a workflow process problem that we could work on? And the only way that we know that is if we receive that feedback and kind of work through those problems together.
Yeah, and talking about feedback, so if you have an hour a week, okay, if you literally just went and picked one of the mailing lists, right? Maybe you really care about Python, maybe you really care about Perl, whatever it is, right? So pick one of those mailing lists, look at the layers that you care about or that you have domain knowledge on or whatever, right? Please go and review the patches coming in. If you think that I am personally able to review 50 to 70 to 100 patches in MetaPython every week, you're dreaming. I do not have the time. So what are you seeing? You see patches come in, you see them get merged, right? Thankfully, we have Kim who's actually continuing to keep that stuff merging. And it is tested on the auto builder and some stuff like this, right? So that's the first thing I would ask. Help us review patches. Help us make sure that every patch coming in has had eyeballs on it, okay? The second thing, if you've got maybe slightly more time, maybe an hour is enough, right? But pick a recipe, enable p-test, okay? As soon as the p-test is enabled, it's way easier to do now. If you have any questions about why it's easier, just ask me. As soon as we have that enabled, that means that can run in automation. That runs in CI. Now we have that data being stored forever, and now we have that ability to actually maybe start wrapping that into the new SBOM formats. And we start actually having a safety critical SBOM report being generated by the Yocto project. We're not there yet, but we could be there. Kate talked about that yesterday. So these are a couple of really, really low-hanging fruit, easy, light touch areas that we could use help in. There's plenty of others, but that's my first two suggestions.
Thanks, Tim. Yeah, I think we might have time for one more.
So one of the things that we're doing in our company and the projects I work on is we try and, the latest projects, we're running off a master constantly. So when upstream folks are changing recipes, we get that stuff immediately. If it breaks stuff, we figure out how to fix it, and I encourage my team to not work around it in our own stuff, but try and contribute patches and comments back upstream. So that's kind of the minimal contributions that we make, but the people on my team that complain about those one-off breakages every couple of weeks, they didn't have to suffer through the transition from Daisy to Thud years ago, and we're still on that product, stuck on Thud. So it's helping us out quite a bit and trying to help the community back.
Yeah, no, thanks, and absolutely every little helps. And there's lots more that can be done, and hopefully we can do it, right? And finding ways that is easy for your companies, easy for you as an individual, as a developer. Let's see how we can get there and move forward. Incremental steps. It's a crawl, walk, run scenario, and we appreciate it's going to take a bit of time. So hopefully, with your help, we can actually get there. So.
Yeah, and as a consultant, just directly to your point, as a consultant, I'm now under NDA, seeing people's code behind the curtain, right? So what do I see? I see a whole lot of BB appends. What are they fixing? Something very, very generic, 90% of the time. It should have been upstreamed. And in fact, that means several of you are all carrying that same change, but it was never upstreamed. So yes, you've got specific needs. we're always going to focus on your own specific needs. Even Yocto project is still going to focus on your own needs to try to make sure you're happy. But we need to be getting that stuff upstreamed.
Awesome. Thank you so much, Tim. Thanks everyone for participating. And if you have any other questions or this spurred some thought, please come to the BOF tomorrow. We would love to see everybody there.
Thank you.
Yeah, thanks so much. So, yeah. That's super cool. I mean, if we're still using a tool that you invented, I mean, that's super cool, right?
Yeah, and it's really awesome to come here and see people talking about it and talking about themselves working on it and improving.
It's almost a
try to do now. Just want to make sure that. Hello, hello. Yeah, we're good. All right, so good afternoon, everyone. I hope you ate well. My name is Ron Munitz, and I'm super happy that you came to my talk. I really hope that you will keep the same level of energy that you had before lunch as the one that you will have during this talk. So our talk today is going to be about the bootstrapping considerations. Anybody here ever used the bootstrap for whatever reason? Good. So I think, I think you are going to be very useful for the overall discussion because you can attest whether some of the things that I'm saying are correct or not. But in addition to that, I would be very happy if you participate also like in discussions because this talk is pretty much divided into two. It is some sort of a workshop, but since it was a little bit difficult to provide some of like the preparation instructions, then we're going to make it like very reproducible at home. Now, the reason I'm saying it right now, even before I introduced myself properly, is that the word reproducible will repeat it during this talk. And it's one of the considerations that will make your life really, really important. Really, really like easier and will make your work really, really better. Okay, so having said that and having careful for people joining in, welcome. My name is Ron Lunitz. I'm the founder and the lead of, it's sort of a venture studio called PSG Holdings. Essentially, we are a consulting company and a training company that built a couple of startups. This is what we've done. We've been around since 2014 full-time, and I started it after leaving a startup that I founded that was doing remote Android devices, which in a way led me to this conference, which is by far my favorite conferences, and I've been in quite a few conferences, about a decade ago in 2013 in San Francisco. There was a wonderful conference called Embedded Linux Conference that right now it's called Embedded Open Source Summit. And I sort of started my Linux Foundation workshop way there. So this is a personal note. Today is like very special for me because the last time I was supposed to speak at this conference, there was an event in Lake Tahoe in 2020, early in 2020, and we all know what happened in early 2020. So now is a happy time, and I really hope that my excitement and happiness will also, that you will also be a part of it. So my hobbies and my, I could say expertise, but that's for others to say. The things that I like doing and the things that I do relatively well are embedded stuff. And embedded can be microcontrollers, and embedded can be microprocessors, and embedded can be everything, like everything is embedded. So one of the things that I'm doing is running a meetup group that is about embedded. It's called Embedded Israel. And some of the reasons that I'm mentioning it is that, remember I say reproducible, then this talk, it's self-contained. However, there are related videos on my YouTube page that are directly related to this talk. And after this talk, there will be additional videos that will be related to this talk. So the idea will be not just building rootfs for Debian, and I hope that everyone here at least know more or less what rootfs is, but also building the rest of the distro in a way that will help you to practice, like to go over things in practice, which can be very important because one of the things that can be a little bit annoying when we build systems is that it takes a lot of time and it takes a lot of space. So I will give some links later, and the slides, of course, will be published. And we'll cover this. If we have enough time, we'll cover some of the promo of like a distro that builds Debian and some other thing, a distro builder. I call it PSG BuildOS that I will release in a couple of weeks. I was hoping to do it by today, but it took a little bit more than I expected. So in general, I'm always happy to have conversations, always happy to have some talks. I'm in the United States for a while, so if you want to catch me while I'm here, happy to, whether it's work or just fun, as long as you're a good person, honest and direct, and say what you think and do what you say, which is like being good overall, nothing to do with work. So that's my email. Feel free to shoot emails. So why am I giving this talk? That's an excellent question. So let's prepare a slide about it. So here's the thing. I've been training embedded Linux and Android internals for a long while. And over the last 2 years, I got into the conclusion, because of a very strong firmware team, firmware developer team, in some autonomous vehicle company, I figured out that embedded engineers that do microcontrollers have some sort of phobia from embedded Linux. Does anyone share this feeling? Like they say, okay, yeah, I see you nodding. It's true, because they say, wow, it's too complex. Wow, it's too big. Wow, there's so many lines of code. There are so many great developers that do kernel work. So many awesome things in open source. Like, how do I even start to handle it? And I always tell them, like, hey, if you did drivers, if you did MCUs, if you debugged hardware stuff, if you debugged microcontroller software stuff, you can do the rest. You just need a little bit of guidance to lift your chin up and be confident. Everything will be OK. You need to start somewhere. So this led to me going and trying to validate this hypothesis while working with them. I was doing contracting and training for like a couple of years. And in the meetup group, I really saw, because obviously, you know, all over the world in the last 2 years, there have been a lot of layoffs, right? So people look for work. And there is challenge and there is competition. And what people come and say a lot of time is that, hey, there is much more like embedded Linux work than microcontroller work. So this conference is actually amazing. And it also covers, I hope that you at least got exposed to it, the Zephyr project, which is amazing, right? And it's been very, very heavily influenced by the design of a lot of embedded Linux constraints, okay, and considerations. And this talk touches some of them, but focuses on something very, very specific, which is the root file system, okay? So the reason this talk exists, one of the reasons is to help microcontroller engineers to have better life in adapting themselves to being embedded Linux engineers. So this is why it's a series of talks, and this is why I repeated it, and hopefully I will not repeat it again until the end, unless there is like specific video I want to mention. So at the end of the talk, or like after the conference, I can go over and like give some tips if anybody like wants to get into it. So in general, when we talk about embedded Linux, we care about 5 things more or less. The 5th one is the hardware. That's the bottom line in the pyramid here. Then the hardware needs something to boot, to jump to, right? We have a power up and we want to go ahead, go to a specific instruction and do something. So there will be some chain of bootloaders, okay? Or all kind of boot code. There will be usually a boot ROM or some BIOS or UEFI code, and then there could be a chain of bootloaders, and this is not covered now. But the important thing is that in the Linux world, this would go and sooner or later load from somewhere, from some persistent storage, from a network, from whatever. It will load a piece of code called the Linux kernel, a piece of statically linked code that, yes, it has expanding capabilities if you heard about loadable kernel modules. And this piece of code, it's just a file that's being loaded into memory and once again jumped to, and then it does a lot of wonderful things. But these wonderful things will not be addressed too much here, okay? So what will be addressed here? One of the wonderful things would be starting loading an executable that we call it init. It has a very well-known process ID that its number is 1, yeah. So you're number 1, you're celebrating. The number is 1. And this thing automagically allows us to do like crazy things, like displaying the presentation here, right? So this is quite amazing. How does it do it? It forks and exec all kind of tasks or processes, depends where you look at. If you look like in the kernel, then everything is task tracked. If you look like at the user space, okay, we can say process, thread, lightweight thread. As far as the kernel is concerned, everything is the same. Tasks tracked, okay? And other operating systems have like their concepts. But this enables us to actually form like an hierarchy of running several entities in a parallel way, in a way that enable people to think, hey, only I get the CPU or the CPUs. Only I'm doing stuff here. But it's not really like that. So scheduling and this kind of constraints are not really related to the user space or to the distribution itself. And it's very important because when people hear, hey, let's optimize, a lot of times they're going to think, let's optimize the runtime. And they're going to think many times about the most complex things. But there are other things that are complex, maybe a little bit less, but dominate some runtime execution by far more than putting some tunables into some scheduler that usually no one understands. Some people understand, but like, come on. So the idea is that we need, after this amazing init process came up and can fork processes, can do some things, we need to do some other workload. And there the distros come. So I can do something as simple as doing nothing, just doing a sleep loop. And this is perfectly valid Linux distro. That's fine. And I can have Debian or Red Hat or whatever. I can have things that are built for me by the Yocto project, which is an amazing, amazing, amazing Swiss knife. It's an amazing tool, but it's very complex to get into, okay? I've been working with Yocto project for years. I see myself as a very strong advisor of Yocto project. I love it. It's amazing. And I'm not saying it because I used to do contracts for the Linux Foundation. I'm saying it objectively. Yocto project is something amazing, which is why it is a reference design for building distributions. Another distribution builder that is quite amazing, and here there are a couple of amazing French people that are also the maintainers of some parts of this project, is Buildroot. It also enables you to come and build distros. But these kind of things are not for everyone. And now let's jump to the present. What happens in the present? What is the most exciting thing that everybody's talking about right now? AI, of course. And who dominates the market without even thinking? Just shoot an answer? Yeah, nobody thought, I love you guys. Exactly. So when somebody wants to say, hey, I'm going to do an AI, and I'm going to do NVIDIA, what distro do they usually use because NVIDIA told them to? Debian, or more precisely, Ubuntu. I don't work for Canonical. I see somebody with the red hat. I don't know if you work there or they just gave you the hat, but like, I don't work for any of those, okay? So we have something that is very, very, very strong. And yes, there will be competition. And actually, this is a golden time for embedded Linux because a lot of companies are just manufacturing other architectures, a lot of time based on like RISC-V, but many times not. And there is and there will be explosion of jobs in embedded Linux. I think it's a very exciting time for people like us to be in, people who like deal with hardware. So what happens is that on the topper level, instead of just doing an init that doesn't do anything, then there are very strong distros that can do AI, like Ubuntu, like Debian, like pretty much everything. And some people need to build them, or some people need to get them, and some people need to run them, which is amazing if I have all the resources in the universe. But then comes the problem. The problem is that just like the very talented people that are superb Node.js developers or Python developers, or I don't know what to say, oh, I know stuff. I did CNCF. I did it on the cloud. Yeah, there is amazing open source support. I have all the packages in the universe. And then they come to a device that has, I don't know, ½ GB of storage. And then what happens? What happens is that they get all the Python and Node.js modules in the world, and they can't do anything because there is no space, right? Because this is how modern development works these days. So this is like a very easy example of what happens when you just go, take your workload, and put it on an embedded device, even if it's an embedded Linux, even if it's like super, super, super strong. There are other concerns like, OK, it's in the field. I power it off, I power it on. Data will corrupt sooner or later, OK? Things will happen. You will have like an embedded device on the field. Data gets corrupt. It doesn't boot anymore. What happens? They fly you to a customer site, and you need to start doing all kinds of things, and then everybody is pissed at you. So there are considerations that are completely different. And if I come and say, all right, they gave me this amazing Debian or Ubuntu distro, and just use it as it is, some bad things are going to happen for me, OK? You know, we like work-life balance. We're going to have very bad balance in everything. We're going to be upset. We're going to hate everyone. And worst, everyone is going to hate us. So we need to be mindful of things. And this is what this lecture is about, speaking about Debian and Ubuntu distros. All right? So what we do in this one is take half of the pyramid off, and we concentrate on 1 and 2, which is having the mechanism to run all kind of binaries, that is having libraries and executables, which Debian gives us, and it will give us using a tool called the Bootstrap that we're going to introduce and see the trade-offs about it. Other thing that we sort of cover, this is why most of this is grayed out, is some choices of how to use an initial root file system and how to actually think of, okay, let's say I have Debian, what init framework I want to use. So one of them, I said that something that just loops and does nothing. Something can just toggle a LED on and off. Another thing can have like a fully fledged systemd. Another could have Android. Android is 1000% Linux. Like I would always say, I mentioned 10 years ago that Android is Linux, but they weren't exactly the same. But since like 2 years ago, maybe, they're billion% the same. Google is heavily invested in the Linux kernel, and everyone is happy. So our objectives are, we're going to look at the Bootstrap, and across the Bootstrap, we're going to explore different Debian distros. There are many, many, many flavors, but the most prominent are Debian and Ubuntu, right? We're going to understand a little bit about package repositories, because this will help us save space or time. Like, anybody here studied computer science? Great. What do we learn about most of the degrees? About the complexity or space-time trade-off, right? You usually can't have both. So this is what it's going to be about, speaking of the packaging. We're going to install some packages and do some recipes that are very, very common. And we're going to go ahead and, as we progress, go and talk about considerations. So I'm going to show all kind of use cases, all right? And for us to be like effective, I'm not going to wait for the downloads of the setup system. But if you have like laptop plugged in and you have like any Ubuntu or Debian system, or actually any Linux system, and you can install a package called the Bootstrap over there. That's one of the advantages of the Bootstrap. You can run it from anywhere, as opposed to Multistrap, for example. Then you're pretty much covered, and you're done, and you can like do some of the same things and see that I'm not bluffing you. I will post some of the scripts that I made for comparisons. I will put them in GitHub, but I'm not a heavy GitHub user. Usually I use something else and in private, but for the talks, I sometimes publish things. So we're going to do that. And after that, we will cover some more constraints and considerations, that can enable you to take this, put it on several devices, most notably an emulator of all kind of variants of QEMU for several architectures, and use it in order to actually work with a system that with a Bootstrap, and we can test like whatever we want over there, do all kind of debugging, tracing in a very easy and reproducible way. Because these are some of the disadvantages of other build systems. You need to start waiting a lot of time, and you need to work really hard in order to modify them. So this is going to be like from the ground out and easy. What you're expected to know, not too much. You need to know that there is a tool called apt that is used in order to install packages with dependencies. In addition to that, there is a tool that is called dpackage, which is used for configuring the Debian package system. It's like a Debian packaging, okay? So anybody ever used apt? Okay, so apt is amazing, right? You want to install, I don't know, VI, and then it gets all kind of dependencies, install them together, and you never need to worry about it. In the past, and also sometimes in the present, you would get tarballs of all kind of source code. You would need to build them, think life is good, only to see that you don't have gazillions of dependencies, and that's what you would do all day and all night, all right? So now we can say, hey, we have Docker, and so on. But Docker came from a need, okay? Now, dpackage is the tool that actually takes those Debian packages and automatically extracts them. It's like an archive with instructions. And one of the nice things about it is that it enables you to track what you have done. So if you want to remove a package, you can then get rid of it. And if you need additional packages, then it has the dependencies. So it's really nice. Okay? So that's the only thing you need to know that exists, pretty much. So let's begin. This talk is more practical than accurate. It's relatively accurate, but in order to be accurate about things, we need to explain every single line and every single bit and every single tool, which is something very nice to do, and I actually usually like doing, but we don't have the entire year, correct? So we're going to show some things here. This is in particular x86-64 OST, but you can use everything here. Also, if you have a RISC-V OST, if it's 64-bit, and you can do everything on ARM64 as well. Everything is like super good and super okay. So what is not accurate? There is one thing that is a little bit annoying, because Debian officially supports RISC-V. You can build Debian root file system for RISC-V, but it doesn't show with the other distros that you build, like with ARM and ARMHF, ARM64, ARMHF, and so on. So getting all like the packages that you need is not in the exact same way. And because I also designed a reference distro for you like to practice and to demonstrate it, then it would need like, okay, this is the different URL and so on and so forth. So for everything RISC-V, I prefer to use Ubuntu. And because it's about selecting a root file system, and as far as you're concerned, you don't really care if you use Debian, Ubuntu, or whatever. The mechanisms are the same. You go, you know the options, and then you choose your alternatives. You are the embedded developers. So our objective is to create a Debian-based, and when I say Debian, I mean also Ubuntu, file system, root file system, following the Debian package convention and the tools that I mentioned, APT, that uses under the hood the package, with minimal effort. So let's start. The minimal effort is called the bootstrap. We have two ways. I already mentioned the AI and the NVIDIA stuff. The first way is I get an installation media or get a storage. It has Ubuntu, it has Debian. That's it. Then I need to start. I don't have space. I don't like what I have. I don't like the XZ packages. In every talk, somebody needs to talk about it. So, or I don't like, I don't know what. I don't like myself. All kind of things. I woke up on the wrong foot. I don't know. So in these cases, I can go start and removing things and customizing. This is one way. It's super legit. The other way is the bootstrap. There are several variants of the bootstrap. I'll show the parameters soon. One of them is for like building. It's called build D. The other one is for fake root. Never mind what it is. The other one is the default, which gets the min base, which is the last one, variant, and then add some packages. And the last one is min base that has like the very, very minimum things that are needed, including the package. So the bootstrap essentially gets packages from all kinds of places, configures some things, and have a Debian root file system that I can cheroot into, and I can theoretically boot as is. But anyone who uses the bootstrap can tell me what is the problem of taking the bootstrap system and trying to run it on top of a Linux kernel directly? So the answer for that is that the bootstrap does not provide you any init. In order to have an init, the speed one, you need to work a little bit. So you could, for example, say, OK, I want to have like some static executable that will be a shell, and that's all I care about. Super legit. Or you can alternatively start and install packages. For example, systemd. So once you've done that, once you start configuring, this is adding on top of the bootstrap. Now, because you absolutely have to add packages in order to have a meaningful root file system, and because you need to configure things, then there is another tool which is called multistrap that has configuration files that enable you to specify which packages you want to install and all kinds of things, and you can just use it. And it's a legit tool, and it's pretty good, and everything is OK. I'll talk about it in one slide. The thing is that there are other distros and distro builders, but the distro builders have significant disadvantages, especially when you want to learn how to be really good in them. The first one, they're complex. Like the learning curve is stiff. And the other one, which cannot be looked away from, is that they take a lot of space on the host. And you require network to do some things, at least for the first setup. So learning by yourself takes time. And practicing takes time. So I've been teaching millions of Yocto project courses. I'm telling you, it takes time. Like it's really, it's not trivial to start embedded Linux development with the Yocto project or build root. You need to introduce a lot of things, and courses cannot be 1 year, like you do them 4 days and like you're done. So there are advantages to use simpler tools. How simple is the tool? It's as simple as this. We install the Bootstrap in our favorite package manager. If I'm on Red Hat, I can also use like DNF or Yum, all good. And then we run the Bootstrap. If we want to, the Bootstrap, a system that I will run, for example, on ARM64, and I'm using x86-64, I specify the arc, okay? I specify the variant, one that I just mentioned. You would usually want to specify the deb variant as min base. That's the name, min base, the minimum basic stuff. You will put the Debian version, for example, Bookworm for Debian 12, or like Lunar or Mantic. I don't remember which Ubuntu is which, okay? Now there's supposed to be another one. I was waiting a little bit for it to come out, but I did not include it because it's like not out yet, okay? I thought it might be because they have their release on April. So it can be, that's the important thing. It doesn't really matter if it's Debian, Ubuntu, or like the other variants, because they use the exact same mechanism. So you can use one and the other interchangeably, and I will show a little bit how the sources works, and then you will see. So the last thing is a URL. The URL you take the packages from. You can use in the main pages to see a little bit about the Bootstrap. So after we do this line, of course, change the variable names with the things that you need. What is the output? What is the outcome? It looks something like this, which looks pretty much like a Linux standard base LSB root file system. So if I have this, I can cheroot into it. Cheroot means that I'm going to get into like this folder, and when I look at like the pwd or do cd /, it will be /. So it enables all kind of tools that expect some hierarchy of the file system to work if they have like the right libraries, which is part of like the permit. So the Bootstrap does that, and Multistrap does exactly that. So why not Multistrap? It's good, but you need to learn all kind of things in order to configure it. You must have Debian to run it, which actually is not a problem at all because there is Docker, there are containers. In 1 second, okay, a little bit, not 1 minute, you have a Debian system that is running and you can run it on top of that. That's perfectly valid. But then, and that actually comes from experience, then you need to start like doing knowledge transfer to other people. And it happens that it's not so easy. I mean, you need to document a lot of things, and it just doesn't work out of the box like the one line of the Bootstrap. So I actually strongly recommend to just use the Bootstrap and then add things on top of it. So what can we do with it? What is doing things on top of it? We can cheroot and do things, like installing packages or just looking around, right? It's our computer, we can do whatever we want. We can run it in a container. Now, when I say run it in a container, yes. I don't work for Docker, right? But who uses Docker here? OK, at least half. So if I do like Docker pull or an image or Docker run image, whatever, then I get file system. I actually get a couple of like directories that are merged together using, depending the Docker driver, usually overlay FS. That is something very, very powerful. And what I can do there is I basically do something like cheroot, but it's an isolated cheroot because then I do not affect if I have my own networking, I have all kinds of things because of a construct in the Linux kernel called namespaces. So this is not a talk about Docker. But when I say I can run it in a container, I mean that I can go ahead and do like a bind mount or like put it like in a volume of Docker. And then in the Docker itself, I can do cheroot if I want to, okay? So these are some of the things that I can do, and it's like very nice. Like it's like very powerful. I can experiment, and worst thing, if I'm not happy about things, yeah, I just ditch it. Everything is good. And I can use it as a root file system for a target device. But for this, I need to have a kernel that works on this target device. And I need to be able to prepare something so that I can actually see things over like a serial terminal over the display and things. And this requires understanding the target. It requires some configuration. So what are the Debian releases? If you go to debian.org releases, it's going to actually do a redirect to an FTP. You will have in the website itself, you will see like a README, and you're welcome to just do it. You'll see like these things. You'll see like a README, and then the list of like the files and folders. And this is also correct like for this morning, actually. So basically, you have like a list of releases. So some of them are ancient, like they are from the 90s, okay? And some of them are under long-term support. So if you need to start something relatively new, but somebody forces you to use them, okay. I mean, it happens. Sometimes people are expecting particular versions of compilers or other tool chains or I don't know what, and they insist on running old things. It happens, okay? But otherwise, you probably want to choose the latest and greatest. So it's good to know what it is. And remember, like the Debian distro parameter. If you don't, let's show it quickly. The deb version. You just put whatever is in the parentheses, and you get a distro. That's it. You get a root fast for it, okay? So this is nice. And if you click them, it's going to get you into several things. So as I mentioned, this HTTP is a redirect to an FTP. And over there, you have several files. And I will cover some of them, but a little quiz. Somebody can tell me what is written here. What is this file? I want to guess. Anybody cares to read it loud? Yeah, so this is LSLR. It could just be LSIR or something like this. Like, why would I have such a file? What's going on here? So apparently, this 15 megabyte of file, it has the context of putting ls-lr if you just download the entire FTP. And if you extract it, apparently it's like 150 megabytes. And this is the contents of an LS. This is unheard of, which means there is a lot of things inside this thing, okay? It's just a text representation. It's unbelievable. In addition to it, you have dists and ZZZ dists, which are more or less the same. I told you it's not going to be accurate. Just going to say that like dist has some links into ZZZ dists, and the reason they did like this so-called redundancy, it's not a redundancy, is that if somebody wants to update a file, which is an important concept, this is why I'm taking a dramatic break. If somebody wants to update a file, friends, then some packages sometimes change. You think you're using a distro today, and tomorrow a component changes, which is why reproducible builds can be very important, because if a component changes and things stop working, I'm not talking to you about vulnerability. Yes, I'm a security guy, yada, yada. But I'm talking to you as an embedded engineer. If some things stop working, you usually don't waste 10 minutes figuring it out, right? It's time consuming and it's annoying, and sometimes it can be, I don't know, a couple, like 10 megabytes can cost you 10 days. And go explain it to your managers or to your customers. And your customers can be your colleagues next door, because usually people like us, we prepare things for other users. And then go explain them that it's like not so trivial because something changed upstream and you don't have like unlimited storage because you use some cloud provider. So it's a problem. So what we have here, like in these dists or ZZ dists folders that one can change, as I mentioned, under like pull the rug under our legs. What we have there is information about packages. And the packages can be Debian packages. And those packages, in order to avoid all kind of like it doesn't need to be like a very malicious hacker or like a very vicious hacker, but in order to avoid all kind of problems, there needs to be a way to verify that when I download something, it's what I get. So for this, I need keys. I need some sort of like integrity mechanism. So the integrity mechanism there is a GPG keys, okay? And what we have here is basically a couple of files that are listed for that. Changelog says what changed over a different version. You will have it under every distro, every version over there. Release is the contents of the different files that we'll have and the digits on it. And release GPG will just be the signature on it. And in release will be a combination of both of them. So the tools can like verify that. What is the tool? For example, the Bootstrap or APT. So let's start looking at optimization constraints. So I took a couple of examples here in several dates just to show how things look like. So if I go ahead and look at Trixie, this is on x86-64. I looked at it at January 14. And this is how I run the Bootstrap. The variant is mean base. This is the folder. This is, sorry, the version, and 1 is the folder. And I did a du-sh on it. And what I got here is 215 megabytes for like the minimal things over there. Out of there, a folder called varlib apt had 50 megabytes. And out of there, a folder called varcache apt has 33 megabytes. Then I said, OK, let's clean some caches. Now, I can tell you that I could just delete these folders, and in a way, if I delete most of the files there, everything will work after an update, OK? So don't worry. But there are more organized tools to do that. So if I go do root to this folder on my computer, right, I don't boot anything, I can go ahead and do apt-get clean, and then I save myself like a good amount of memory, which is pretty nice, OK? Now, the same release, a couple of months before that, had a different size. So remember I told you, hey, what if something changes? It's the same release, like it's rolling. This is a Trixie. It's not yet stable. It's not like latest. But also the stable ones can change. So we need to be mindful of the sizes, because later we're going to package it into a root file system and try to put it on an embedded device. I'm not dramatic for no reason. These things, debugging things and understanding things, it takes time. And sometimes you don't have a solution because you cannot change the hardware. So you need to change the software, guys. And this is America, right? We love America. In America, what do we like doing most in corporates? After that, yeah. I don't know if you can see your teammates. Say, OK, like, let's make a meeting with the manager of the manager of the manager of the manager of this team and the other team and the third team and so on. And then let's see what we do. And by this time, like, nothing is going to happen. You have a product to ship, so come on. So we need to be mindful. We need to understand what's going on. And sometimes we need these meetings because we want to say, hey, you're using like a Node.js for writing hello world. And the hello world module is 5,000 gigabytes. So I don't want that. Just do an inline assembly statement, call a system call number 4 or whatever, and that's it. So these things are serious. So this is an example. I'll show a couple of examples. I mean, I also have like a recording in ASCII Cinema, and I'll upload it like to some GitHub. Or maybe I'll show it. Let's see how the time goes. So a couple of such more experiments. So the previous one was min base, OK? So it was 250 megabytes, the same one on the top of the floor. And now I did not use min base. I used like the default one. And I can see that before cleaning the caches, it's 311 megabytes. Friends, it's super significant. I don't have enough words to emphasize how terrible 100 megabytes can be on an embedded device. Okay? It's unforgivable. Okay? It's outrageous. Now, if I look at the file systems, and I try to look what is the difference between them, I can see that I have etc apt that are exactly the same. Why? Because the differences between min base and non-min base is which packages they use, not where they take the packages from. So you have a file called sources.list and sources.list.d that populate these kind of things. A couple of more examples, and then I show some like the relations between the packages and the different like systems. And I'm using slides, but if you have laptops, you can just go ahead and go to these directories and see what's going on. Okay, it's like more time effective like this. Those who've been in my training know that I am strongly against slides. Okay, so but sometimes they really help. So this is something else. Anybody can tell me what, I know we had lunch, but anybody can tell me what is different in this slide? As opposed to the previous slide, let me just refresh your memory. Look at this line. Huh? Yeah, so this is called cross the bootstrapping. Here I'm telling you, hey, I'm on architecture. Let's say I'm on MIPS. And I'm going to build your root file system for another architecture. So here we can see that comparing to this 215 megabyte that we have here it's 234 megabytes for ARM64, which could be counterintuitive, right? I mean, ARM, it's an embedded architecture. But they build things how they build things. You cannot compare apples to oranges. So now we're going to go and do like another experiment. And here it's, like, again, like 100 megabytes more. So the takeaway from here is that, yeah, mean base and the default are two different worlds. And it's a sin to use, I'm sorry if somebody likes it, it's a sin to not use the minimum possible. It's a sin. Don't be lazy. Come on. If you really like the things, figure out what packages are added, and then have a script and apt install them later. So the same thing on the same distro. This is ARM64. This was taken on 2024, January 14. And I had a course here at Zux, I think, a couple of months before that. And I took like a screenshot of that. Okay, the course was about embedded Linux, and I just show, I use Debian as some demos sometimes, because what we do in my courses is usually build from scratch some things. So look what happened here, like the same version, 10 megabytes of difference. This is terrible. This is terrible, okay? This is unbelievable. It's really terrible. So what do I do? So we have 10 megabyte difference in the mean base variant over 5 months. If it's not reproducible, then I'm done. Those 10 megabytes can mean the world. So we have a problem. That's a lot. It's 10 megabytes, you know, for like people who do CNCF. Yeah, who cares? We have the cloud. 10 megabytes is outrageous, okay, are outrageous. So if you have limited storage, you need to be mindful. There is no way around it. There is no other acceptable answer. Which means that when you have to maintain a system that somebody did, and they give you all kind of scripts, and I'm not talking about something like Yocto project or build root, which, by the way, a maintainer is here at the back of the room. This is something that if somebody gives you scripts that they made in the company, and people do it all the time, yeah, this is the script that you run. This is what you use for CI/CD. You can't trust them. You need to understand what they do, because then they're going to leave, and then it's going to backfire on you, okay? This is unacceptable. The first thing you come when you take a new project and somebody put all together all kind of like scripts and said, this is how we build. This is how Qualcomm told us to build. This is how MediaTek told us to build. This is how I don't know what. You immediately say, no, I'm not playing. I want to see what's going on, okay? So super, super, super important. You're an embedded guru. You're expected to know what you're doing. Critical. This is, I think, the most important takeaway. So look how many times in every slide I'm talking about the storage and the space. So as promised, let's see what we have. We did like this, the comparisons between like the two ETSs. So we have like this sources list, and there we will have like something that will start with deb, and we'll have a URL, as I mentioned before, and we'll have the name of the distro, and then where to take it from. It could be main, universe, multiverse. You can name it however you want it, because if you control the FTP, it just translates into some paths in the FTP. So in addition to it, which is important because security is important, but it's also important because sometimes when we just build a system and figure out what we want or prepare mirrors ourselves, we want it to work effectively. So we don't care about security at all. We just want no questions. We want simple processes. We don't want anybody to change like a certificate authorities under the hand. We don't care. We just want to be effective. And then when we have customers inside our company or outside of it, worry about it. So you can have all kind of trusted, it's not exactly like root authorities, but you have trusted GPGs. So you can say, OK, if this guy said, yeah, this is the package, and I signed it, then they could tell you, all right, I want it in. And otherwise, you will fail it. It happens in every possible distro. So you just need to be mindful of that. Why? Because if you do care about security, you will probably want to change it, especially if you have like your own distros. And you want to make sure that somebody did not compromise the particular key, and like then you're using software that you don't want to use. Okay? And these things happened time after time after time. Like in 2011, I think, something like not exactly like this, but similar in concept happened like with the Linux kernel. So there were no like releases for a couple of months. And now, you know, everybody's like going bananas about the XZ things. This is not the same thing, but they said, oh, maybe the developer the computer was compromised. So maybe yes, but maybe they're part of like another APT, Advanced Persistent Threat group. So you can't know, but you need to be mindful of these things, okay? So let's connect it back like to the sizing. So what we have like here is that we have in the var lib that took like 49 megabytes. We have something that looks very much like the line here. So it adds up, it makes sense. We have like deb.debian.org, we have deb.debian.org. Instead of, and then we have like this, and we have, instead of like slash, we have like underscores, and instead of spaces, we have underscores because we want to be reasonable, okay? And if we look at this file, you will see that this file is a very, 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 very long text file. And if we look at it and compare the output to it to a command called apt-cache show, then we'll see that for each package, it shows the exact same lines. So there is logic in this management. There is logic in this package management. It doesn't come like out of nowhere. It's not in a vacuum. Now a little bit about more caches. So we have also, before, sorry, we looked at the var apt list, which is text files, but we have additional caches. Some of the caches, and the most important one, would be where we download packages. So if we download packages somewhere, and we want to remove a package and then put it again, we don't need to access the internet again, which can be useful. But what is the problem? It takes space, which is terrible. So again, you see how my feelings are towards wasting space, right? So look what we have here. So essentially, we have this apt-cache, and the rest of them, upon initial, the bootstrap will not be interesting. debconf is some configuration files. And ldconfig is not useful at this point. It's used in order when we use shared libraries in general in Linux, that there is something that is called the LD cache. Like it tells us, OK, this is where you load some SO from. So it optimizes like some of the places of the linker. And this var cache ldconfig, actually, it's counterintuitive, but it's actually used to create another cache file under etc. OK. So we talked about things. Let's refresh our mind a little bit about some older distros to see what are the differences in sizes. Just look at it. We already understand the concept. So 206, like in Bookworm, that is number 12. And in the other one, it's 214. The takeaway from here is that sometimes there is more space in more recent versions, and sometimes there is less space. There are no rules. There are no rules. You need to understand what you're doing, and you need to analyze what you're doing. Okay? Now let's look about the difference between Debian and Ubuntu. The difference is there is essentially no difference. You change the URL when you debootstrap it. But if I look at the Lunar distro here, I can see that instead of 200 and something megabytes, it's 124 megabytes. Okay? That's a very significant difference. However, when I see this, I can also understand and see that there is a reason for being like much lower on space. And the reason is that less tools are included because it's pretty much the same distro, the same operating system. So the idea and the takeaway from this slide is that it can actually be very useful and very easy to use Ubuntu instead of using Debian sometimes, okay? And one of the nice things about Ubuntu is that it supports like RISC-V directly out of the box, which is very nice. So here we have a couple of more comparisons. You see it like in the slides later. So these are the takeaways. And one of the other takeaways is that if we want to use ARM, and this is the Embedded Linux Conference, it's Embedded Open Source Summit. If we want to use ARM, and of course it's also true for x86-64 versus x86-32, but usually you don't want to use x86-32 anymore, to be honest. Let's see the difference in the same distro between two different architectures. So ARM64, for the same Lunar distro of Ubuntu, it will be 143 megabytes compared to 115. So that's a lot. Again, it's like 30 megabytes. So the takeaway is that if I don't really need 64-bit support, I can compromise some things and gain other things. So I need to understand what my demands are or what my requirements are. Okay? So this is what we learned from this. And just one little thing, like the URLs are a little bit different, not only between Ubuntu or Debian, but also between where I take the non-native or like the non-original posts. That would be like x86-64 would be the default one usually. But where I take this or where I take ports, that would be usually other architectures. Okay? Now we continue. So other things we need to be aware of. What we need to be aware of is that we want to create a root file system, and it will have permissions. So what will happen if I come and want to change the permissions of some directory, change the owner to be root as a regular user? Can I do it? Most probably not. So here, what we do is we need to use sudo in order to generate the bootstrap. But we all know that using superuser is a very bad practice, right? So these days, it's not a very bad practice because we do it on a Docker and we finish it. That's how we do it. But sometimes maybe we don't have Docker, maybe we don't want to use it, yada, yada, yada. So the idea is that there is a tool called fake root and fake cheroot that enable us to run in a place where a process thinks that is a super user, and then it can modify the attributes on a file, because everyone can change attributes on a file if they created it. They can change it without using like the actual system calls that modify it. So one can go ahead and on a regular system just use this fake cheroot here and do it like that. So the Bootstrap supports it with variant fake cheroot, and this is how you use it, but you usually have several problems. So in order to be a little bit like more advancing on it, I show several caveats, okay? But it's important to know what things are, but we cannot concentrate on all caveats because there are so many of them, okay? So basically the idea is that you do something like fake cheroot and then fake root, and over there run the Bootstrap with a fake cheroot variant. But this also has its disadvantages, and you'd need to debug it. So usually what I want to tell you is that just don't do that, okay? So great. We covered the Bootstrap. We understood the sizes. We understood the caches. We bored some people. Yes, it could be very boring. But we entertained others. Yes, it can be very entertaining. Now what? Now what do we do with it? So what we do with it is we cheroot and knock ourselves out. Or we edit files externally because our motivation is to build a Debian distro. So we need to configure things, okay? We're building it ourselves. We started from low. We didn't start like from whatever they provided us, like a fully fledged gigs system. So it's up to us to customize it. Now, I already mentioned the security part with the GPGs, but in general, I just want to emphasize it. When we are the crafter of our system, our motivation is to work fast. So for our experimentation, and there is no shame in experimenting. We all experiment. We're never sure exactly what we want to do, okay? So for our effectiveness, a lot of time we just want to say, okay, let's trust everything. And it helps us also in resolving all kind of other caveats, especially with foreign architectures, the architectures we don't run on, because sometimes the Bootstrap will tell us something like that. We cheroot into the Bootstrap system, and then we run apt-get update. And then it will start saying, hey, I cannot access dev null. I cannot access TMP. I cannot access this. I cannot access that. So when this happens, and it will probably happen, you will take a deep breath, and give it what it wants. Just mount another file system, just mount this, mount that. But you need to be aware that these kind of things happen because it's annoying and Googling for solution take time. Okay. So basically, there are some things that you can do and some things that you cannot do. You cannot do everything. But one of the very nice things that you can do is automagically building for foreign architecture. And I want to say a couple of words on how this works. There is something called bin format MISC that enables you to just run a file. And just like when you have like the shebang bin bash, right? When you run something like this, actually the kernel itself takes control of this file. It says, hey, what's in the beginning of the file? It's bin bash or whatever is after the shebang. Let's search for an executable that runs this and give the rest of the file as a parameter for it. So this is called an interpreter, and it's called a bin format. Like if I look at the Linux kernel, I said no this, but sorry. If I look at the Linux kernel source code, then I will see that we have bin formats, several bin formats here. The default one would be ELF. It will have a magic number. Magic number is just like hexes, okay, of like 7F ELF. That's how you notice it. And we can see also that we have bin format script that does exactly what I mentioned, looks for the shebang and then interprets it. And we can see that we have bin format MISC. So the idea with the Bootstrap is that it has two phases. One of them would get packages, but then it needs to do things on the file system itself. So in the past, there would be like two phases, and there still are two phases. One of them would be the first stage where you take the packages, and second one, you would put QEMU user and then do all kind of shenanigans on it. Now, usually the Bootstrap expects you to have QEMU user installed, but it's just another package that you can install. And then, because of this bin format MISC, it figures out, okay, it's 7F ELF. What is the architecture? And according to the architecture, user space can register an interpreter for that, and the interpreter will be QEMU user, and then you can automatically run things of other architectures. So you can use this trick not necessarily for the Bootstrap, also for running Python code, Java code, and so on. And it's something that is important to know, because if you don't have this, then you cannot cross the Bootstrap, okay? So this is something that is good to know. And other things that are good to know is that you can't do everything in the Bootstrap. And there are several caveats, which will be the what we're going to start when covering the next module, which is how things look at the target. Now, I just want to give an intro to that. When you run the Bootstrap, you're not running on a real operating system. You're running on your own operating system. So if you chroot and then try to get some DHCP address, you install packages, but you want to get like an IP address via DHCP, or want to populate etcresolve.com, or want to do all kind of system control things, you're still running on your host. And if you want to go move that to the target, and you have all kind of garbage that was done during the process, you are in a problem, okay? And if you want to clean up your history and say, hey, this is my new root file system that I presented, you're also sort of in a problem. So you need to be mindful of these kind of things, okay? And sometimes you don't even know what to expect. So sometimes, if you already have something running on your device, you may want to just change it with your file system and start experimenting, okay? So what we've done so far was we covered what the Bootstrap is, talked about differences between the different Debian distro flavors. We talked about considerations of size, about how things look at the FTP, and we emphasized several times that size matters huge time in terms of what distro we select. Having said that, let's go to the second part of this workshop that is about preparing for target usage. Are there any questions so far? Yes, please. So this is an excellent question. The question was, why would I use this? I have experience with Yocto. Why would I use this over Yocto? So the answer many times would be, you should go with Yocto. It's a wonderful distro. However, you would be surprised on the number of people that want to have APT tools that are available for them in the entire mechanism. And you would be surprised when people say, OK, Yocto, what is Yocto? Why do I need it? How do I use it? Oh, it looks too complex. And it is complex. So now you are good with Yocto. Congratulations. But how did you feel about it when you first used it? Excuse me? It's complicated. So you are lucky to have the time to tackle a mission and get to learn it. Or maybe you had like good guidance, but it takes time. It's complicated. And understanding how things are, even when you're super experienced with it, is not easy. And I see myself as extremely experienced with the Yocto project. I've done a lot of projects with the Yocto project. And I'm telling you, it's not easy. I know where to look for stuff which is good. And I know Bitbake very well. And I know like the dev tools. And I know how to look for things. But sometimes I also struggle. I mean, because this is how it is. But the truth is that many times people say, OK, I can run Ubuntu. I can run everything that I have on this computer. But I just want it on the field. And I say, let's just put the same distro. So you put them Ubuntu, and then you need to start preparing it and optimizing it, because they don't necessarily have it. OK? Any other questions so far? Yes, please. You touched a very good point. By the way, maybe I should pass the microphone. So you said that it looks like a good fit for like integrating with Buildroot, and that sometimes you just miss a package like in Buildroot and need to go ahead and rebuild everything again. Now, let's talk about both distros, because you guys are experienced. So you are talking out of experience, not like just out of curiosity. The thing is that the objective of both Buildroot and Yocto project is to build everything, including tool chains, including like the kernel, including that. And because of that, and because they are like commercial tools that need to do several things, then they're highly configurable, okay? So I actually saved this for the last part, which is a reference distro that I made up that does some of these things, but without building the tool chains, and it does things much faster, actually. So the idea is that in Buildroot is by far easier to use than Yocto project. It's millions of times easier, and I honestly say that I prefer the Yocto project, okay? However, also in Buildroot, just like you said, you need to rebuild things again. And it takes tons of time because it needs to calculate dependencies. It doesn't want to make mistakes. So it's not good for experimenting. This is the truth. And to work with Buildroot, you need to feel comfortable enough, like with the kernel makefile system, actually. With kbuild, it's not the kernel. The kernel is just one part. But these are the other things, which is excellent. I mean, if you know one project, you know pretty much the other project, so it's pretty good. But the build time that it takes, it is significant. If you just want to work on your root file system, let's say maybe you don't even want to repackage everything. I mean, I will talk about packaging like later. Maybe you just don't need a lot of the things, so why go over all of the things? And Buildroot itself, yeah, you can do a recipe for just building Debian, include APT tools, actually add Bootstrap as part of the things and do that. But Buildroot is not meant for that. So yeah, these are two excellent points. Thank you for making them, friends. All right. So some things that we would want to do after we bootstrapped. We actually want to start populating things. Okay. So the first thing would go ahead, okay, assume we're able to boot our system. Then we package it like a root file system, put it somewhere, and are able to go ahead and switch root into it, or root into it, or the target itself. So the idea is that we need an init script. I already mentioned it, right? Or an init executable. And now I need to start choosing from it, because without it, I will just kernel panic. Init script cannot exit. The init process cannot exit. This will be a kernel panic. And the other thing is that essentially, I don't really get anything by default by the bootstrap. So I need to think what I want. Okay? So if I think what I want, then I need to start choosing between different frameworks. And there, real optimization starts. Because the default, de facto standard of the init framework is systemd. I love it when people come and say Android because they know that I did a lot of AOSP work. Yeah, the default is systemd. And systemd is very powerful. You need to learn some things to customize it, but it's manageable. But what is the problem with systemd? It's big. This is a huge problem. But what is the other problem? It's slow. It's super slow. Not because it's bad, but because it does a lot of things. Choose one tool for the job. If you want to do everything together, there will be compromises. So other things that are a little bit lighter and useful are, for example, OpenRC. Gentoo uses it. sysv, there is a project called finit sysv. I will demonstrate. It's like super, 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 super easy. Okay? And BusyBox itself, the amazing Swiss knife, has a framework of its own that you can easily customize, and just show like an example. So this choice opens the door to a whole set of trade-offs. Speed, of course, image size, flexibility, and more. So you need to start understanding what are the criteria that you want when designing your root file system. You need it also for a Yocto project and build root. You need it for everything, but you must be mindful. Another thing is, OK, we have a root file system. We know we want to have it on a target. What happens when I want to start providing hardware support? So I can go ahead and say, no problem. I built every possible thing into the kernel, and that's it. But what's the problem then? Of course, size. That's one of the problems. So a lot of embedded distros and Android in the past would go ahead and say, OK, you want to use loadable kernel modules? I don't know if you know like the speech of Biden. I have one thing to tell you. Don't. So like this is one thing, and actually this is how Google started. Now all other, Google I mean with Android, now all other vendors, they just disabled modules and that's it. All other vendors, sooner or later, started adding loadable kernel modules, and later on Google came up with something for Android called the generic kernel image. And the generic kernel image is generic because it absolutely needs to have loadable kernel modules to augment for it. So loadable kernel modules they're pretty much essential. I mean, if it's good for Google and Android, then I'm not saying Google is like the best reference for a lot of things. But if it's good for Android, it's probably good for you. It is how it is. This is also like a good tip. Except for the build system, which is, I better not talk about it anymore. It's so huge, you need too much. All right. So if I need to put removable kernel modules, awesome. I build the kernel. I copy the modules, and I'm good. Make module installed, do dep mod, and I'm great. But what is the problem? I need to insert them somehow, and this is the responsibility of the user space. So the distro needs to put the tools for that. Now I can go ahead and install kmod package, and I can go ahead and just use BusyBox. So if I come and install BusyBox from the Debian repositories, usually I will not have modprobe. And modprobe is important because it resolves dependencies. I usually have insmod, but not have modprobe. So I need to understand what each tool gives me. Okay, so if maybe I want to build BusyBox myself, or just use kmod, or maybe I just want to implement modprobe. It's a system call, and I will parse like the dependencies on all the files that are over there. So there are other considerations that are not necessarily about the runtime itself. Remember, I told you that sometimes the customers are like your colleagues. Sometimes your customer will be somebody that is experienced and knows things. Maybe it will be a kernel developer itself, okay? Maybe it will be somebody who is a kernel developer, but just in a team that doesn't have the entire source code and wants to just use something, the reference, that is made for building modules. So there is something called make modules prepare, like in the Linux kernel. And if you do this, instead of building the entire tree, then it takes nothing time. And it's much smaller. This day, like if you make a def config of almost every distro except for RISC-V, then the storage that it will consume for you will be like 2 gigs. Like the ARM64 default kernel build is huge. It's pretty big. Because they include a lot of things, because it needs to be tested on a lot of things. If you want to make it specified, good, you know what you're doing. Customize it yourself. The def config are meant for like testing. So the idea is that you can go ahead and just give them 10 megabytes instead of giving them 2 gigabytes, which is like it's a game changer. And also if you do like a CI/CD, it's also a game changer. So you need to deliberately avoid some warning as error, which is build mod post form, but it's not a kernel course, so never mind. This is what it's going to tell you. You'll tell it, yeah, I know what I'm doing, and you continue with it, okay? All right. So having said that, these things that I mentioned are generic. Both the systemd and, both the systemd and the kernel modules. And there is one little more thing that we need to start seeing if we want to start having more reasonable workload. We may want to use syslog. We may want to have some logging. And we may want to add users. And we may want to actually say, OK, we want to use AppArmor if it's like Debian, or even if it's Debian, use other Linux security module like SE Linux or so on. So we need to start doing things. Maybe we want to put credentials. Maybe we want to have a root password. Maybe we want to disable it. Maybe we want automatic login. Maybe we want to enable graphics. Maybe we don't want to enable graphics. Maybe we want to enable SSH. You see where I'm going? These are the kind of things that we need to start thinking after we put like the minimal basic system. So let's look at some recipes. And we'll talk about some of the things that we have, for example, in Ubuntu Lunar. That's 2304. Mantic then is 2310. And we'll talk about some tasks that are common and is worth doing. And again, we'll talk about some optimization constraints, because sometimes I don't need some things. And sometimes, actually most of the times, I will not boot to my root file systems directly from the kernel. But I would rather have an init from FS that would almost always have what? Start with B. BusyBox. And if I have BusyBox, it can do a lot of things. Okay? So one of the things has to do with networking. So let's say I want to enable networking. When somebody tells me I want networking, I take a deep breath, and I don't lose my stuff on them. Why? Because it's too broad. What do you mean by you want networking? What do you want? And here comes the things. If I need to optimize the system, I need to understand exactly what I want. For example, if I don't have Wi-Fi, I absolutely don't want to start building like packages that are related to Wi-Fi. Wi-Fi is an okay case, but if I don't have Bluetooth, I definitely don't want Blues included in it, because it's huge, okay? If I don't need SSH, if I don't want to use DHCP, or I don't need to have like complex DHCP stuff, then maybe I just would be better with just BusyBox and using micro UDHCP, and that's it, client, and that's it. So there are all kinds of considerations over there. Network managers, whether it's NetPlan or the network manager, they're very powerful, but a lot of time I just don't need them. I'll give you a typical example of when I would want to use like a network manager. Let's say that I am here and I want to go to the hotel later, and then I want to come back here, and I want to always be connected over Wi-Fi to where I arrive. So in order to remember the networks, I need to either code, which I don't want to, or have something like Network Manager or NetPlan take care of it for me. But nothing comes for free, okay? Not only in terms of size, but also in terms of customization. Sometimes learning to figure out how more complex tools works takes a lot of time. And sometimes even Google or ChatGPT doesn't help you, or Gemini or whatever, okay? So the idea is to understand what we want. It's a very important thing. Now, one of the most important things to understand about the kernel, about the networking, especially for embedded Linux, is which entity of the system is responsible for what. So yes, user space will most probably configure all kind of things. A notable exception is some parameters for the kernel if you want to use NFS, for example. So the kernel can do DHCP itself, and it will keep it, okay? But the kernel will keep it. It will know what it goes, what it does. But user space will not know about it, really. So you need to start doing some configurations from the user space. And once something is configured in the kernel, you don't need to configure it itself again. So NFS is one example. But also, if you had BusyBox running in an init from FS or in a RAM disk, and you configured the network over there, and you don't need anything else, you don't need to start doing some complex things, you can disregard almost everything that is related to network on your root file system. And you can save a lot of things over there, okay? So why? Because the kernel does the networking. Other tools usually do the configurations. So it's very simple, and then you can just put @resolve conf and to something that like will resolve DNS, and then you're done. You don't need to do too much things. You can save things there. You can also put BusyBox on the root file system as well. But assuming you want to work like in a more standard way, these are the packages you'd want to install. How to install, apt-get install, and so on. So IPRoute2 gives the IP util. BusyBox also have it. ISC DHCP client is a DHCP client that depends on IP route. When I say depend, even if you don't install it, it will install it anyway. If you don't want them, as I mentioned, you can use BusyBox. It has a micro DHCP client. So one of the problems is, and this is a huge problem, is that if you install it, if you want to install it, it will not be necessarily in the main repository. Remember I told you that in Ubuntu, for example, like it's like 100 megabytes less? So you need to go ahead and look where it is. And to look where it is, when you do apt-get update, remember those huge lists? It's going to download them. So you need to remember like to clean after yourself so that when you are on the target, if you want to support apt-update, you will not get other things from this repository again. So a takeaway from it is that sometimes when you configure sources list because you want a very particular tool, perhaps you want, after doing this, edit again the sources list and get rid of it, because a failing apt-get update on a storage restricted target can destroy the target if you don't plan properly. Okay. So I already mentioned that BusyBox is very useful and it gives you a lot of tools, also telnet, pings, and so on. So let's say we say, okay, good, let's use BusyBox. I have micro DHCPC. And I'm talking about it not because it's the specific topic of the talk, but it's because it's a very important tool set. When we do DHCP, everything works automatically. But what really happens when we do DHCP with a client that is like less capable? The thing is that it can get the lease, okay? I do micro DHCPC, or it's also the same like on DHCP client itself. And DH client, usually it's called. And the thing is that if I just do it, it will work. I will get an IP address. I first need to do IP link setup and so on to actually have the interface up. But then I will have a problem. It will work, but I will not have an IP address really. Why? Because DHCP tools, they receive like a list. They receive all kind of like hey, this is what you should do. But somebody should call the commands on the net interface. Somebody should call IP link set or ifconfig or IP route or so on. So it turns out there's something that is called a DHCP hook. And instead of just running micro DHCPC on the interface, you can give it a script. And in this case, I just call it like DHCP hook. It will look something like this. It will get a callback device. You will have the slides. You will have this, but thank you. I'm flattered that you take pictures. Tell me if I look good. I'm joking. So here's the thing. We have like a parameter. It gives us an argument, like the script is called with an argument by UDHCPC. And if the argument is bound, then I'm in business. Okay? What do I mean I'm in business? If the argument is bound, I know for a fact that I got a DHCP list, and it will have the IP address, the net mask, and what is the default router, the default gateway. I will have these things. So this enables me to later on a script call IP address add to set up like my interface, and call IP route add. I can put it in network, in class, I can put the default gateway, and then I'm done. Like I do all kind of things that I get automatically with the DH client. I get them automatically with adding a couple of lines of script. So I can make it better, I can check what is the list time, I can do all kind of things. But for the basics, super powerful. And it's important to know because most people don't even know. They say, okay, oh no, I run a UDHCP and it doesn't work. I don't get IP. What now? Okay, so other tools, let's get rid of like this busy box already. Other tools would be like if I want to have ping or like traceroute or telnet or SSH or nmap, I can go ahead and install this. A list of tools. I can go ahead and like install them. Other things that I would usually want to do is perhaps set a default password or provide an auto login or not provide any login at all. It's also legit. So I would go ahead and, for example, use the password util, and I can also use password-l to prevent the logins. So L locks and -u unlocks. So sometimes when I have the bootstrap, you will notice that sometimes you can use sudo but not log in as root. So these are the kind of things that are not always trivial, and it's good to know because this is how you unlock like the account. Okay, you can then start adding users and groups and so on and so forth, and then you can start, having like a login or bypassing it. So for having a login, now comes something that everybody always meets sooner or later, and no, but there doesn't exist a single person that didn't ever try to bring up a Linux system that actually worked, but then the terminal was stuck or something didn't work out, even if they have UART or even the F-script. So for this, it's important to understand what are the teletype devices, what are TTY. So the idea is this. If I go now and hit Control-Alt F3, what would happen? I'm running Linux, I'm running Ubuntu. Huh? Blank page, here probably, yeah. That's a good. I will just go and I will move to like another virtual console that will enable me to log in probably and do all kind of things. So the idea is that this exists because someone, in this case systemd, told him, hey, please open a VT. It's called like a virtual terminal or virtual console. So there is open VT and change VT commands. But what happens if I have like a serial device? I need to start defining, hey, this is the serial device. This is the baud rate. This is what you do. And I need to tell him, if I boot, this is the first thing that you do in a serial device. You go and do like a get TTY that will show you like a login prompt. Get TTY is a program that knows to handle like the TTY, whether it's like a serial device or non-serial device. And I can tell him what to do. So one of the things I can tell him, hey, no login, and then it will just give me shell. Other thing that I can do is run login, run PAM, a pluggable access module that will verify passwords, verify all kind of things, fingerprinting, you name it. Another thing that I can do is decide to not run get TTY at all and just run SH, and then I will have shell, okay, for example. So these things, get TTY, shell, something, somebody needs to run them. And this somebody will be the init framework, okay? So something that is common for all framework that use login, because usually we'll use login. There are several files. There is etc issue that will print a message to me, etc issue net, that this is important, or our login that nobody probably uses, or telnet that a lot of time people don't use either. This file will automatically show something when you connect over telnet or our login. But on SSH, it will not show you a message when you connect. Why? Because maybe you don't want to know, for security reasons, if somebody, like if there is something on this server, like I don't respond, maybe it's like for this reason or not. So the idea is that I can start configuring, if I do want to notify them of something, I can go ahead and say, okay, in the SSH server configuration, show me a banner, and then show this file, okay? So here's banner at issue.net. Like the name is completely arbitrary, okay? And so after that, like after logging in, I will have message of the day that I can use, for example, to do automatic things like, hey, show something, this is okay, or run all kind of things. So if you like log into an Ubuntu or demo and tell you, hey, there are so many updates, it's because they put a script file under etc update message of the day, okay? So other thing I can start doing is starting customizing. So I will go over it like very quickly. I can decide for development only that I permit root login, and then I can SSH to my target. Okay, it can be useful. Okay, so with the Bootstrap, we added packages and we covered all kind of things. What's next? Since I was running in the Bootstrap on my host, it's very possible that I was running all kind of tools. For example, hey, I wanted to do apt-get update, and I could not access the server. Why? Because there's no DNS defined. So I could populate etc resolve.conf with something, and then I would go to a target and nothing would work. And this would happen a lot, because a lot of time people pre-provision things that just don't work. Or they put Google website like 8888, but let's say maybe you're in China, and then it's blocked. All kind of things can happen. So the idea is, it's the wrong slide. So the idea is that you want to go ahead and be mindful of that, of what's going on. And then if you do apt-get on the target or on the chroot, you'll figure out very quickly if you are mindful of these things, like, hey, why doesn't apt go? It just cannot access the DNS server, and so on and so forth. So this is very classic. You put like something like in QEMU, and then in user mode, because you don't want to start setting up tap devices because it's a complex setup. And it just doesn't work after you put it like on another target. So this kind of thing is relevant, because if you can test things, entire system, like on a Linux, like a Linux kernel, bootloaders, and so on QEMU before testing on the hardware, it's amazing, because many times you don't even have the hardware when you will have already finished most of the development. I actually gave a talk about it in 2014 at the ELC. And I was using some tricks, but it's like, it's what everybody does like now. So speaking of frameworks, I already mentioned BusyBox. We can do something very easy, not to do anything. Do BusyBox, run spin init, and it will tell us, hey, hit any key to get a shell. This is called the ask first target. I'll put an enter and I'll have a shell, no login, no nothing, great. Otherwise, BusyBox would expect me to populate an etc init tab file, which is very simple. It has like a target, and I can tell it like which command line to run, and then it will just go ahead and run it, for example, like this message. Otherwise, I can also go ahead and do like respawning. If this process crashes, restart it. When you see minus, it means that it's not that there will be job control on it, which means you can do Control Z, FG, like forward. Okay, and one of the things I can do is run like a DHCP script. So I will have networking automatically. So when you have systems that just work, it's because people did things for you. And if people did not do things for you, then you need to do it. Other frameworks and caveats, and we'll finish in a couple of minutes. We have 5 more minutes? Okay, good, excellent. So we have, for example, for finit, I mentioned like the TTY things. Let's say that I have a finit by default. They don't really know what is, if I'm running ARM64, and what is like the serial device that I have. Maybe I have 5 serial devices. So I can go ahead and tell it, hey, on these run levels, use this TTY. This is the terminal. Linux will be colorful, for example. It can be VT100 and so on. No clear means do not clear like the kernel messages, okay? No login means boom, you get a shell. Otherwise, it will call login automatically. So this is one thing, okay? So I need to populate the corresponding file, okay? And I can use finit that will get me login. Again, if I use universe component in Ubuntu, for example, which means a lot of like 100 megabytes. Systemd is very powerful, but it's a topic for a course, not for like a talk. So I'll just mention that we already mentioned the disadvantages that they have, size and so on and so forth. But I'll mention something super annoying that you probably met. I have the following things. I wait, and then it will either say timed out waiting for, or it will count forever. Anybody ever encountered it? It happens when I have like a file system that is not okay. It happens when something is not defined well. It happens when I want to put something on a TTY, and it doesn't work. So I need to start understanding what's going on. So for systemd, I will have services. And for example, I can go ahead and hack something very quickly by figuring out, OK, where we have TTY word, let's just add our interface, like TTY AMA 0 or TTYS 0. But then I will not necessarily have like the all green state in systemd, because there are other dependencies and so on and so forth. So there are static services for TTY. There are no static services, and some trick that can work to make things like very, very, very easy. If I go ahead and modify get TTY static, is to disable, in addition to it, the serial get TTY that systemd itself generates because it uses udev, and it's a lot like of concept, in order to enumerate what hardware you have. So there are all kinds of tricks that you need to put the building blocks and understand what systemd wants to do, because it has like a lot of implicit targets. Now let's say that you're not sure which init script you want to use, init framework. You may have a couple of them. And in this case, they can collide. Like you install systemd, then you install sysinit, and you have some links. And then you go, you do reboot, for example, or shut down. And it will be a link to the corresponding things in your framework, to systemd or to sysvinit or so on. But it will say, hey, if the link points to the wrong place, because the package manager is usually not expected to have several things in parallel. We do it as a development trick to figure out what we want. So trivial commands may not work. So we need to be mindful of that. Either remove the other packages, use update alternatives in Debian Ubuntu, or set up the links ourselves. So these are some of the things that like we have, and like we're starting to run out of time. So just one more thing about systemd. If you see kernel logs, you can have systemd working. The idea is to go ahead and give it a command line systemd unit equals rescue target, and then it will not go ahead. It will have the very same terminal with the very same parameters, and like the same TTY will just work, okay? And there are some reasons for that, for the recovery, because it should just use the same std in, std out, and std over the same one. It's something called TTY force. So the takeaway, that it's really okay to try several things, but you need to understand what works, what doesn't work, and don't interchange them. And that systemd is super powerful, and everybody knows it. It's a de facto standard, but sometimes for embedded Linux, it's just not good enough. Okay? So before we conclude, a couple of more things. I recommend it perhaps to like clean the caches, because it saves a lot of data. So what if you keep the caches and do save them somewhere? If you save them somewhere, there is a chance that at some point you would want to reinstall things. And in this case, if you removed the caches directories, then there might not be all the history of what you've done. It doesn't take a lot of like space. So you can overcome these kind of things by like these questions that are being asked here. You can overcome it simply by deciding, hey, ahead of time, I'm just going to go ahead and install the package maintainer version, or like these files. Where would this be relevant? When you modify things like the SSH config files and stuff like that. Why am I mentioning it? Because figuring out the differences manually, first of all, it's manual, so it's not good. It's not like a git diff. It's not so trivial on the eyes. So the last thing that I want to point here is offline and reproducible builds. Because we already know that we want to have the same build over and over again, you can actually download the caches without building things. It can facilitate things and keep them aside. How do you do it? When you do apt-get, you're just going to do --download only, copy them later when you're preparing like the file system to like var lib or and var cache apt, respectively. And then if you have like the same caches, you're going to be using the same code. If you started from the Bootstrap version. So we're running out of time, but I'm just saying that this is an insanely strong tip, and it can help you do all kind of things. And if you follow up on some things that I will post, and I'm happy to take some questions after we're done, and I will release a distro that like all kind of scripts that it builds an entire distro, like also the kernel and things like that. It just doesn't build like the tool chains because it doesn't need them. So we have all kind of configuration options that enable us to really go ahead and play with these constraints, like caches here, caches there, saving them in overlays, making it writable, and so on. Other things that are important and out of the scope now, when you want to do forward of video and audio, different flavors behave completely differently, depending also if we use Wayland or X server. And they also behave completely differently depending of whether we use Jack or like a Pipewire or a Pulse server, like for Pulse audio. So many times you're going to work on a target and you're going to do everything perfectly, forward everything well, but you want to forward it to a host. And you need to understand how the host is configured. This is super important because otherwise debugging can be annoying. And for this, actually, I mentioned that there's this meetup that I'm organizing. It's far away from here, but there are some videos. So I cover some of it on how to use these kind of things for working on Mac OS as if it were Linux by forwarding X out of like a Docker or out of like a QEMU and forwarding Pulse audio. So this is relatively nice. For security, I don't handle this lightly at all, not me and not my company. We do services for that. We do things both defensive, both offensive, both training, but this is not this. So having said that, what do we do next? We'll not do the backup slides that I inserted because we're running out of time. But do whatever you want. I mean, you're the builders. This is a builders summit. This is what we do. So I just hope that like what we have here helped to organize your thoughts about some things. And some of the next thing that we will do, and I will just post videos about it, and about OTA over-the-air updates. I hope that I could speak in the next Embedded Open Source Summit in Europe, because it's a continuation of this talk, actually. We can do all kinds of things, like gathering the requirement, understanding how to partition things, understand package update strategy size, like what we want on the device, what we want to get from networks, understand what we want if things go bad, a recovery golden image, like store something in one place, but then do we want to have caches or not? What packages do we want? And it turns out that we can have actually the same common mechanism for several things together, like to have whatever we want to flash, to have A/B updates, to have a recovery golden image, and to have over-the-air updates. And instead of having like the packages or the caches time after time after time, just store them in one common place and be able to update them as well. So these things and these objectives, this is a little bit of teaser, will be in something that I call PSG BuildOS. You can follow me like on LinkedIn, and I will happily show it to you. Because I will upload more videos, and I uploaded more videos prior to that actually deal with the things of like how exactly the initramfs in Ubuntu and Debian works. Like there were a couple of videos of that because somebody asked me in a meetup. So I said, okay, I'll answer it like in a video, and instead of 10 minutes, it was like 3 hours, but it was okay. And yeah, there are some videos here, and you're more than welcome to just contact me, okay? And I will put like everything online, including the slides. And if you want me to tell you when I publish like the code of the distro that does some of the things that I mentioned, then just you can just email me. I will definitely not spam you. PSG BuildOS EOSS 24 on the subject line, or follow me because I will put it like on LinkedIn. But that's it. So thank you so much for. We're done with time, right? Okay, so thank you so much for attending the talk and for surviving after lunch. And I really hope that you had a good time. And is there time for a couple of questions? So do I have more time for more topics? Because I have backup slides or not?
Technically, you're right on time.
Yeah, no.
You have a break, so if people want
Okay, break is great, but a couple of questions perhaps? Yes, please. That's a couple, yeah. You know what? Let me just see if it works. Do I need to turn it on?
No, I think it.
How many?
Check.
How many engineers do it take? Yes.
So the Bootstrap produces a tree of files that you could cheroot into, right? So it doesn't produce an image; it produces files in a folder. So do you see any issues with trying to get into like a Flash-based file system for the image, like a UBI, UBIFS?
Not
as
really.
long as the kernel supports it.
No, not really, because it doesn't matter if you have like a tree of files or if you have like one file or you have nothing, or if you have journal or don't have a journal. The concept of file system, actually of the virtual file system, the kernel supports it as you mentioned, but the kernel supports it via means of something called VFS, like virtual file system, which means that no matter what you have, what is the layout of the file system, the API is the same for user space. So if you can mount it, that is, take something called superblock, which is like the descriptor of like a file system. There are several of them, but it's not a file system course. And if it can mount it and mount it succeed, that's it. You're done. It doesn't really matter what you have there. What does matter in Flash file system is if you are unmindful and decide that it's okay to go ahead and delete everything all the time. This because then you're going to wear the Flash, although we need to be very honest here, because Flash are like, there are Flash controllers, there are like controllers in Flash devices that are not even related to the operating system really, and they do excellent work, and they know better than anyone. I mean, they know what they do. So you said 2 questions, but that was the first.
Yes, thank you. And second one was, you compared the sizes of Debian and Ubuntu, and it was a little surprising that Ubuntu was actually slimmer.
Yeah.
And my last foray into the Bootstrap, I went for Debian because I thought Debian would actually be smaller. Sorry, no, I went into Ubuntu and I had trouble with apt. I had 64 megabytes of RAM, so really low RAM, and apt crashed because it couldn't run with 64 megabytes. Do you know if Debian's packaging tools fare better, like maybe?
How many megabytes did you have?
64.
64. And did you mount a TempFS?
I think so.
So again, what was 64 megabytes? Like
64
the
megabytes
RAM
was the
or
total RAM of the whole system.
So
Very tight.
no, it would be the same, because if they can get RAM, they would chew it. But the question is, this is actually a very, very good subject, because if we were, remember I said, okay, the other developers, if you weren't using like Flash storage devices and so on, I would say, yeah, no problem. Put a swap partition or put a swap file and use it. Right. And a lot of time we do use this kind of thing because we don't have a choice. But the question is whether we do have a choice or not. If you can do this, if you can use swap even just for that, then it's fine. I mean, do the apt-get and don't do it anymore. But then the question should be, why do you really need to update things on the target? And how frequently you need to do it? Because let's not lie to ourselves. I just said, oh, don't erase it all the time. If you write some things once a year to a storage device, it's not the end of the world. Like probably the devices will be thrown to the garbage much before we will hurt them. Let's be real here. But that is a superb question. Thank you for asking it. Okay, so having said that, we're done, and thank you. And please, this is like my number also if you want, and please be in touch. And enjoy the conference. This is, seriously, I mean, I'm really objective. This is my favorite conference, and I really, there are superb people here, and it's like a really amazing place for us people, you know, with our interested, with like-minded individuals to hang out. and super smart people, and like I picked out so many things in these conferences, like so many things, and it's just great. So keep enjoying, and I'll get off the mic, and I'm happy, to keep talking. So thank you so much for having my talk.
and then it
But it's
should
not-
start working.
Yeah, I got a training about this, so yeah, but I did.
Okay. Okay. Thank you.
Thank you.
Yeah. Good afternoon and welcome. I think I'll wait another couple of minutes for people who are still like finishing the coffee break. And then we'll start. Thanks for waiting. No, I think it should, right? Okay, thank you. So let's begin then. So my name is Vitaly Wool, and I work for Consulco. So as you could have heard, Consulco is a distributed company spanning across both the US and Europe, and I'm like the northernmost part of Consulco. So that said, the Swedish one. So I was working for various companies dealing with embedded Linux primarily since 2003, so that's been a while. And since 2009, I work off of Sweden, consulting for companies like Sony Mobile and Ericsson and other Swedish customers, Volvo, for instance. So I have a dual role as a staff engineer at Consulco Group and as managing director of the Swedish subsidiary of the bigger Consulco. So that's why they crowned me on this picture. The crown went sideways, and it's not even a penguin, but whatever. Well, anyway, that's me. And I'm going to be talking about a certain piece of kernel software, a Z-swap backend, trying to make its way into the mainline. And I'm going to talk about that backend per se, and how it was written and what the algorithms are that I use there. And then I'll tell another story about rewriting that in Rust and how it ended up. And we will try to draw some conclusions about possibilities of using Rust in various subsystems, to our best knowledge as of now and what the perspectives are. So we'll go through swapping and how swapping is organized and what are the backends for Z-swap and what is Z-block in particular, the one that I'm trying to introduce into the mainline. And then we pass over to Rust and the problems and solutions that I had to apply to make the Rust one work. We'll do some comparisons, the fun part, and we'll try to do the conclusions. Swapping per se, I guess everyone just knows about it. So I have these slides just in case, if you're interested. So we can go through them, or we can just skip those and save time for questions. So if you really don't want to listen about this, just raise your hand, please. But I will just do a quick introduction, quick go through these slides. So what we're talking about is the swapping subsystem in the Linux kernel, which is a part of the memory management subsystem. And swapping is basically using secondary storage for data that is not used or almost not used. So we save memory by pushing rarely used pages out of it to somewhere, to a secondary storage, which is most likely an SSD or a flash device. But then, especially in embedded systems with not so high-speed storages, if we take a Raspberry Pi, for example, then there is an SD card, and it can be quite slow. So we are, in fact, trading memory for performance, and we may end up in a situation where performance is not really OK for us. So we need to have something in between. We have to increase the flexibility to trade between the memory size and performance. Thank you. So this is where Z-swap comes in. Z-swap is a compressed cache for for the pages that are being swapped out, it's a write-back cache. So the operation is quite simple. It stands in between the memory management, the ordinary memory management, and the swapping itself into the persistent storage. So there's a pool of pages, and these pages are compressed to save the space. So when the page is first swapped out, it's not actually swapped into the storage. It is swapped into this pool in a compressed state. And then ZSwap has two types of backends. So there's a compression backend that has to be selected for ZSwap. ZSwap doesn't deal with compression itself. It uses crypto API, and you can select a specific compression backend. And then there's an allocation backend that is also selectable. And currently we have 3 allocation backends in the kernel called ZBud, ZSmalloc, and Z3fold. And they register themselves in ZSwap by means of ZPool API, and then ZSwap calls callbacks from registered backend to allocate small amounts of space for compressed pages. Why do we need specific allocators? That's a very simple question that has a simple answer, because the normal, ordinary kernel allocators are targeting allocations mostly of page size and up. And we are, on the contrary, trying to make things as efficient as possible, storing very small chunks of data. That said, pages that are maybe not completely full or mostly empty, in fact, that compress well. So a compressed page can be basically from 2 bytes up to 496 if we take the standard 4K pages. And so we have a very specific case of the objects that we allocate the memory for, and so we need specific allocators. And there are 3. As I said, there's ZBud, which stores up to 2 objects per page. ZSmalloc, that has a very complicated but very optimized algorithm of storing objects, and they can span across several pages, and there is quite a bit of MMU setup to make these things work. I'm not going to go really down into this because it does deserve a separate talk. And then there is Z3fold, which basically I have written at some point as an extension to ZBud, and then it sort of started living its own life. Still, it has a restriction of up to 3 objects per page. So it doesn't have requirements, hard requirements on the hardware that ZSmalloc does, but still it's substantially beyond ZSmalloc if we compare the allocators. Well, unscientifically, and just to sort of to have a picture of where we are, because this is just a very averaged comparison. So if we take a look at average performance of allocator backends, then we can see that they're just almost on par with ZSmalloc being the quickest. And then ZSmalloc is also providing the best compression. So it's definitely the first-hand choice currently. And Z3fold is being phased out, so its days are limited. But then, I think, or I thought, we would still need something not as heavyweight as ZSmalloc, doing more or less the same thing. So this is where ZBlock might come into play, but we will get to this. So just as a reference, this is the API, this is the structure that every allocator has to fill in and register for ZSwap to be aware about it and be able to select it. This is also just a reference. We will talk about it later, but it's just a convenience slide to be able to go back to it should there be some questions. So, okay, ZBlock. ZBlock is a simple high-density allocator for small objects. And the idea is to allocate blocks of pages and store same or almost same size objects in these pages as if there's an array. So what we do is we allocate, for instance, we allocate 2 pages. So this is order 1 allocation by calling get free pages, as you can see there. And so we get 8K of RAM. And then, for instance, if we want to split it in 11 parts, so then how we do it? This is also pretty simple. We need to store a header. A ZBlock header is 48 bytes, so it's in the beginning. And then we divide the rest of the space in 11 equal blocks. So it's 740 bytes for each block. And then we have a very small remainder, which is just 4 bytes, which you can see on the chart below. So it's really not that easy to see the header, the 48 bytes header is very small. And then the 4 bytes, they're actually present on the chart, but you can't see it because it's very small compared to the overall size of the block. So this is a high density allocator. So we don't spend a lot of RAM in vain. And the thing is that the higher order we take, the less overhead we have because the header stays the same. So if we take order 2 allocations, so 16K, then the leftmost part, which is the header, shouldn't be visible also. So what we do if we want to allocate memory for an object, so we find an appropriate block type that we can fit in our object best in. And then we have the list of blocks of this block type that we search through to find an empty slot. And if we find such a block, we allocate a slot in that block. If we don't, we allocate a new block. And the object becomes the first object in this new block. And, well, the free algorithm works pretty much the same way but backwards. So we find the slot corresponding to a handle that we hold or we get. We mark that slot as free, and then we check if the block is completely free, then we free the whole block. So if we want to compare ZBlock with the existing allocator backends, we can say that it's still very simple, has small code footprint. It's highly configurable because we can actually specify the table of block lists in many ways. So I'm thinking of extending the functionality to have this as a module parameter, but as of now, this is a static table, but this may be changed, and this probably should be changed. It's operating fast. It doesn't have ratio limit like Z3fold or ZBud. It doesn't require MMU like ZSmalloc because it doesn't use the physically uncontiguous pages to form contiguous pages in the virtual space. And it has a compression ratio somewhere between Z3fold and ZSmalloc. So ZSmalloc is still the best compression-wise, but it's a lot more complicated and occupies a lot more space, but we can see that. So if we extend the previous chart with Z block, so we can see that it is supposedly having superior performance and good enough compression. So the ultimate aim is to submit it to the mainline and have it supersede Z3fold. So Z3fold will be obsolete and Z block should take over. But then the question is, should we really, or should I really, or us as a community, people interested in things, should we try to push the standard C-based version, or maybe promote the Rust version, debug the Rust version, and submit it instead? So that's the question. But first of all, how did it come to Rust? That's also a good question, because Rust has been circulating. It's a buzzword, and there's been a bit of controversy around Rust and whether it should or should not be in the kernel, and whether it's better than C or worse than C, and all these talks, all these controversies. You know what I'm talking about. It's always like people have strong opinion about things. So I was always interested in trying out Rust, but it wasn't that easy because the syntax is kind of, you have to get used to it. It's not exactly something that is easy to comprehend in the beginning. At least it wasn't easy for me. But since there were definitely good things about Rust, like memory safety, the most advertised feature of Rust as a language, and easiness or alleged easiness of programming, and minimization of possible errors while you're coding, like for instance variables that are immutable by default. So if you inadvertently try to change them, then the compiler will bark on you. Still, once again, the rumors were there were some things that are not so good about Rust, like the kernel support is immature and compilers are not bug-free, and there was a bit of a scandal recently that absolutely did not concern Linux Rust development in any way, but still there was a problem, the security problem with Rust applications and Rust compiler in Windows. So we can talk about this later, but still, I don't want to go too deep into this. This is off topic, but the maturity is questionable, and there are some people, as usual, saying that it just doesn't matter, everything is all right, and there are also people over-exaggerating the maturity. So it's hard to get a feeling about this unless you actually dive into this. But these were like the preconditions the rumors that I heard when I was, in the beginning of this journey. And then since the good things definitely, in my eyes, overweigh the bad things, at least up to a point. Oops. I don't know what's happening. Let's try to do it like that. Okay, or not okay. Well, almost okay. Yeah, sorry about that. So once again, the good things overweigh the bad things, at least up to a point where you want to start playing with stuff. And then there was a message on one of the conferences held in Sweden from Linus, not the very big Linus, but still quite a well-known one, who used to be my neighbor there in Sweden at some point. So he was living up above me. So that's how we sort of, met in person, offline. But that's also another story. So my neighbor, my former neighbor, said, well, Rust is awesome, but it shouldn't be deployed in drivers, but rather in subsystems, targeting USB stack and networking stack first and foremost, because these two are basically the most problematic when it comes to memory security issues. Well, I don't have that much of a grasp into the USB stack or networking stack, but I was working a lot with memory management, so I thought, well, I have my code, which I'm about to push to the community to try to push it into the main line. Why don't I just try to rewrite it in Rust and see what happens? And so I did. And I have to admit that, at least for me, because I'm not a Rust guru, not at all, I'm just starting to play with it. Yeah, I guess I'm not a projector guru as well. Sorry about that. Yeah. Not sure what's happening. So I'll try to continue talking. So the amount of effort to set up the environment to be able to successfully compile Rust drivers or Rust subsystems in the kernel was a lot higher than I anticipated. So I knew it wouldn't be a very easy one, but at the end of the day, it turned out to be a bigger problem than I thought it should. Once again, this is my personal opinion, but my personal opinion is the environment setup for Rust is still kind of messy. You need to fulfill a lot of requirements just to start building things. You can't use Rust compiler that comes with your Linux distribution, be that Ubuntu or Fedora or Debian or whatnot. And then you need to have a very specific Rust compiler version to build your kernel, and that is likely to change when you switch to another kernel revision. So if you go up a kernel revision, you probably should change the Rust compiler as well. And this is something that I absolutely don't like. I was working on a project where we had a similar experience, but with Python. So there was a huge software stack written in Python, and it was only functioning properly with Python 3.8.1. Not more, not less. And to me, that signals about the fragility of the system. And I don't want the system to be fragile. If I'm diving into the development of something, I don't want the development tools to be fragile. So this is still problematic in my opinion. The whole setup to be able to compile Rust source code into the kernel, the whole setup is problematic. Those problems are solvable, and there are two tips that I believe everyone should be aware of, and that is documentation is your friend, and quick start for Rust, that's a good thing. And there is a check to verify that the setup is working, this make Rust available, and that works okay for basically all the purposes that I tried it for. But to get there, to be able to compile things in Rust, to get there where you have this Rust available, successful, it's going to take a while, or at least it took a while for me. Then another thing, well, I knew it before, so it's not, as opposed to the environment setup, this didn't come as a surprise. The support for non-x86 targets is not complete, and well, you know, Rust was in kernel mostly for x86, and then quite recently, just less than a month ago, there was finally the merge for ARM64 support, which went into 6.9, which I tried to backport to 6.6, the Raspbian kernel, because I was initially testing stuff on Raspberry Pi as a well-known and easy-to-get reference board. But I didn't quite succeed. I mean, I was able to compile, but it just wasn't working. So I turned to x86 and Coemo, and that worked better for me. That doesn't necessarily say anything about the ARM64 support. I guess it's quite fine in 6.9. Maybe I did something wrong when I was backporting stuff. But that's also something that other people would do, because not many distributions run with 6.9, right? So if you recompile something, or if you do just a single module development for an older kernel, then you could experience some problems as well. Maybe it would be okay for you, but maybe not. So you have to be prepared. And then finally, the support for the 32-bit ARM targets is still lacking, and it's not really clear when it will be available. And that is a bit of an issue, because I work with 32-bit ARM targets also, and I want that block to work on the targets too. But obviously, if I do it in Rust, then I won't be able to. So that's one of the biggest stoppers. And we'll try to, we'll get to this. It will pop up in summary as well. But let's go to specifics, the Z block, and how do we Rustify the existing code? How do we rewrite the code in Rust? And it goes in several how should I put it? Not the blocks, in several portions. So first of all, the registration, since we are going to communicate with the code written in C, that being Z-swap itself. So, and Z-pool, we need to register our backend using the C call, call to the function Z-pool register driver. So we need to be compatible with this. And Z-pool register driver expects the structure filled in properly in the C way, and that structure should be rendered for Rust. And there's a tool called bindgen to do it automatically, or otherwise you can do it manually. If you do it automatically, that's my experience, as with the most tools generating code out automatically, it's really hard to read it afterwards. So pretty much all the automatically generated code is hard to be read by a human being. So I took an effort to render the structure myself, so you can see it as a bit of it down below. So it takes a while, but it's not that bad. And I hope you can see the similarity between the C structure to the right and the combination of structures in Rust down below. There's also a bit of a problem with list head structure. It's hard to render it from C to Rust automatically. So I just did something because I don't work. I mean, Zlog itself doesn't work with list head. It doesn't work with Linux kernel linked lists. So just do it as 2 pointers, basically. So that's what I did. Rustify algorithms. Well, you know, algorithm is it's a very loud word. There are no complicated algorithms in Zblog. Everything is very simple. So algorithms are just re-implemented. Allocation, pretty much the same. Array search, pretty much the same. You cannot use memset to initialize arrays. So that's, I can't say it's a bummer, but that is something that you need to keep in mind. But there are means to initialize arrays in Rust so that you don't have to do it one by one for each element of the array. If you want to set everything to 0, so then you have the ability to do it, for instance, in the kind of a constructor, you know, the function called new. So you can initialize all the elements to 0, or well, a 0 pointer to something, and that works well. Not as simple as memset, but this is the price that you have to pay when you actually have a real array, and as you do in Rust, and not a block of memory where supposedly the elements of same type are sitting one by one. The final thing, and that is where I had the most problems with, is to re-implement or use the locking mechanisms. Zblog uses spin locks, and there are spin locks in Rust, or there is an API, the interface for spin locks in Rust. And to be honest, I don't really like it. But that's maybe because I don't understand it well. That I also keep in mind every time I say something like this, because once again, I'm not a Rust pro. I'm just trying it on. But my personal opinion is sometimes you just need a mechanism to lock and unlock and nothing else. And spin locks in Rust are also made with safety in mind. And in my opinion, this is where safety was chosen over sanity. because initializing spin locks is complicated, and the API is complicated to a certain extent, too complicated, and all of that just to be able to just take a lock and not release it. So in Rust, you take a lock, and then it's released when you go out of section where it was taken, which is okay. I mean, it's a good thing. It minimizes the ability to make a mistake. But on the other hand, spin locks are supposed to be a fine-grained mechanism, and as a fine-grained mechanism, I want it to be fully controllable. And that said, I want to be able to do locking and unlocking myself. This is not exactly possible unless you export the initial C API, and this is I don't particularly like about the spin lock API in Rust. Oh, well, the kernel spin lock API for Rust. So that was what I had like the most trouble with. But then again, at some point, the Rust re-implementation was ready. And so we are going to the fun part, comparisons. And first of all, we compare the sizes of object files for ARM64 and x86-64, stripped and unstripped. And you can see, first of all, that Z-block, the C implementation, is producing the object file with quite a small footprint. So that's also an advantage over Z3fold, for instance, which it is supposedly going to supersede. A lot smaller. The size is a lot smaller than the one for ZS-malloc, sorry, as well. And it's almost on par. It's comparable to ZBud, even though ZBud has way worse compression ratio. So this is nice. I mean, well, Z-block, this is nice. But then, as you see on the unstripped part for x86-64, the Rust version of Z-block is like 2 times bigger, but that's mostly for the debugging symbols. And if you do the stripping, surprisingly, I wasn't absolutely expecting this. Surprisingly, the Rust object version is smaller than the C one. So the code size for the Z-block Rust is smaller than the one for the Z-block. And then there was some testing. First of all, just performance testing on Raspberry Pi to see where we stand with Z-block, the original one, the C1, versus ZS-malloc versus Z3fold. And you can see the Z-block being the one on the bottom for each of the graphs, and the darkest one. So the darkest one is basically on par with ZBud, and it's usually faster than ZS-malloc. So we do have an edge over ZS-malloc because you cannot compete with it when it comes to the compression ratio, but simplicity and performance, well, we do have an edge. And then once again, I wasn't able to collect the results for Z-block Rust on Raspberry Pi, so I switched on QEMU, and then the times were faster. The turnaround time was faster. Once it did hang, I guess it's my bug. But however, there are three successful runs, and we can see that it's basically on par. The Rust version and the C version of Z-block, those two are basically on par. Okay, so where does it leave us? To make a short summary, well, there is a point in using Rust. Maybe the display adapter doesn't like Rust. I don't know. We should rewrite the driver in Rust for this one. Yeah. So there is definitely a point. Despite all the immaturity, alleged immaturity or real immaturity, the code is executing fast, and the footprint is small, at least for x86-64, where we get stable results. And it's actually smaller than the one that GCC has provided. So that is basically a good pro that is that gives Rust an edge. Another thing is, well, it's not easy to get going with Rust, or at least it wasn't easy for me. Maybe younger people who are not like C-centric wouldn't have that issue. Well, I had some. The real memory safety of the specific implementation, well, pretty much, I guess, any implementation of Rust stuff in the kernel is questionable because it has to communicate to C code, so there are still many sections that you have to mark as unsafe because otherwise Rust compiler would not allow those. But still, if you have an idea on how to keep those things isolated, that might not be an issue. But you need to remember that memory safety in Rust is only true when you don't use the unsafe sections, and you can't get away without using unsafe sections if you do kernel development. So it's not a silver bullet, but you can use it wisely. If you use those unsafe sections wisely, then it should still be okay. But you need to keep this in mind. And finally, the most disappointing thing is that the support for architectures that we in our development in targeting deem important, like 32-bit ARM, is still missing, and that is basically to this time the main and probably the only stopper for me to submit the Rust version of ZBlock instead of the C version. And yeah. The conclusion is, since ZBlock should work on low-end architectures, because this is where most of its advantages over ZS-malloc are visible. So we have it in bold, small RAM footprint, and then 32-bit architectures, and then without MMU. And to fulfill these bullets, we still need to use the C version. Even though the implementations, both the C one and the Rust one, work equally well where they are comparable. So what can we say? We need to keep on trying, and maybe we need to participate in the ARM32 support for Rust to be able to use Rust versions of subsystem implementations, backend implementations, because as of now, this lacking support is the thing that stops us embedded people from actually using Rust more and more. But on the other hand, the Rust in kernel is actually working, and you can use it, and that sort of gives us the hope that both Rust and C drivers, both Rust and C code, can coexist to the mutual benefit and to the benefit of the kernel ecosystem. So that was it. Thanks for your attention. I think we have some minutes for questions, so if you have questions, you're very welcome.
Hello.
Hi.
I wanted to ask what ARM architecture are you actually missing specifically? Because there's support for multiple ARM32-bit architectures. And also, if you have looked into LLVM, looking if there's an implementation for that.
The support in kernel that has been merged, the ARM support in kernel only covers 64-bit.
Okay.
So, to be honest, I don't know what exactly is missing for 32-bit kernel support for ARM. But I guess it might be related to the types that may be 32-bit and maybe 64-bit, like integer. Or long, but not long, because long is long is 32 on ARM 32 and 64 on ARM 64, and it's it obviously should be mapped to another ROS type. I don't know. That's just thinking out loud. But the thing is, currently only ARM 64 is supported in the kernel for Rust.
Okay, I'm not familiar with the kernel specifically. And also just a comment for the lock implementation. If you want to free it before, you just have to drop the object and it will free it automatically. You are talking about having that problem, so just.
Yeah, I don't want to drop the object. I want to explicitly call spin unlock.
Yeah, but.
So I understand that you can, or maybe I don't. But my understanding is that you can arrange a specific block, like in curly brackets, and when you go off this block, and if you take a spin lock in the block and then you go off this block, then it's automatically released. But it's how should I put it? To me as a C person, because I am a C person, I'm not trying to pretend I am a C person. To me as a C person, it is more convenient to see where I actually did release it, rather than to find the brackets that define a block where it will be implicitly released. So that's to a point that's a matter of taste, right? But for me, it's more convenient to see where it's explicitly released. At least when I do some fine-grained locking, and when I use spin locks, I do fine-grained locking because I don't want to block preemption for a long time. Okay.
Yeah, but you can manually call drop function, so your object will be freed, and in the case of spin lock, it will be released when you call the spin lock, the drop on the spin lock, and you can do it manually. You are not required to only do it implicitly, and in your situation, it can help you to have a more fine-grained control on when it is released.
Okay, thank you. I will take another look at this. Thanks.
Any other questions?
Well, I guess not. And then, if you have any further questions, just find me somewhere, because I guess I need to empty the place for the next speaker. I don't want to, stand in the way. Thanks a lot for your attention.
We're not doing anything virtual or recording, are we? Are we starting at 4:55 or 5? So we're late already is what you're telling me. Okay. As usual. Okay. Well, thank you, everybody, for coming. This feels very familiar. I've been running BOFs for quite some time. I think I know a number of you here. I see the peanut gallery forming up here in the front. Tim gets his own microphone. Oh, very cool. Thank you. So I wanted to just launch in and talk a little bit about RISC-V and RISE for anybody who is not familiar. Anybody familiar with RISC-V? I think probably everybody in the room. Anybody familiar with RISE? Only a few. Okay, well then good. I actually do have something substantial to share. So RISC-V, we use RISC-V. Just so everybody knows, my name is Jeffro. I've been in open source circles for a little while. And for the last 3 years, I've been at Red Hat. But for the 2 years before that, I was a program manager for RISC-V International and helped convert it from RISC-V Foundation to RISC-V International. It was an extremely fun project and continues to be a fun project that we are actually addressing now from Red Hat as well. So hopefully I'll be able to cover a little bit of that. What do we mean when we talk about RISC-V? We use the one name to mean many things. It's an open instruction set architecture primarily. RISC-V came from UC Berkeley in about 2010. I think it was when it was first published. And formed as a foundation, an open source foundation in 2015. In 2019, the foundation was restructured and moved underneath the Linux Foundation as a contracted project. And over the course of the next 2 years, we increased the staff from 2 to 15. We increased the membership substantially. And since then, after building up a large technical organization underneath that was much better organized than previously, we have now passed, I think, 52 extensions into the original ISA. So that is an exceptional accomplishment, which I can take no credit, but I'm very, very pleased that it has happened, and RISC-V is emerging as the standard that it is. RISC-V, of course, can support both open and proprietary cores. The core is just the expression of the ISA. The ISA remains open, even though it does support proprietary cores as well. There are a number of open and proprietary cores out on the marketplace right now, and a number of groups that are forming to create both kinds. There is a software ecosystem supporting these cores. It is somewhat behind the times a little bit, and that is actually going to be the purpose of RISE, which we'll talk about in a few seconds. There is certainly a business ecosystem in developing, promoting RISC-V. The RISC-V international membership spans globally across 70 countries at least, and it's roughly 1/3 in North America, 1/3 in Asia, and 1/3 in Europe. And I believe they're up to 3,000 members now. So that includes individual members as well. So of corporate members, I believe there are roughly 750.
So it is a very big and vibrant ecosystem, and it is very important for an open source ecosystem that it be multiple voices. And so by that measure, we feel that RISC-V is extremely healthy. There is an extensive community surrounding the RISC-V architecture that has nothing to do with corporate America. Certainly the original RISC-V mailing lists are still around as Google groups. They're still very active. And there are many other communities supporting the RISC-V ecosystem, which we'll get into here in just a second. From a hardware ecosystem perspective, there are some really interesting projects. CHIPS Alliance through the Linux Foundation is one. It is a group of companies that are collaborating on creating SoC designs. Beagleboard.org has just announced, I think, their second or third Beagle V RISC-V based Beagleboard. And then the Open Hardware Group is a very interesting organization underneath the Eclipse Foundation. Open Hardware Group is a collection of SoC designers who get together and create SoCs based on open cores. And the result is also open source. So what you end up with is a full-fledged SoC design that is open all the way down to the transistors. Some of these are actually burned in silicon. A lot of them are available as FPGA cores or as in QEMU. And they are a great representation of the RISC-V community. I added a few names here just to show which hardware providers are out there. This is by no means a complete list, and anybody's inclusion or exclusion on this list should not indicate any kind of a preference, because there are many companies out there, even that are exploring RISC-V, that we never hear about within the community. And they include hardware providers, service providers, systems integrators, software providers like Red Hat, which we'll cover on the next slide. And also a lot of academic and labs, academic institutions and labs. UC Berkeley is still very much involved. The Chinese Academy of Sciences is quite involved. MIT and the CSAIL group has been a member since the very beginning. ETH Zurich is a university that is one of the providers of those open cores that are so popular. And then Rios Labs is actually a lab in China that was created in order to support the RISC-V ecosystem in China from a hardware perspective. And they all provide open cores. I believe also, if I remember correctly, that RISC-V was recently chosen as the national instruction set architecture of Pakistan, which sounds kind of odd, but when you think about it, that means that, you know, in today's world where sovereignty is actually, you know, an important issue from the point of view of intellectual property, that makes perfect sense for a country like Pakistan. They also have been very active in the community within RISC-V International. So the software ecosystem is more my playing field. This includes operating systems, firmware, development tools, libraries, etc. And there are a number of large distros now that support RISC-V, including FreeBSD, including Zephyr, including Linux, of course. Many distros under Linux, including Fedora, Ubuntu, SUSE, etc. There are some gaps that have been identified, and there was a group recently that has formed called the RISE project. In fact, we're celebrating our first anniversary in about a month. RISE is short for RISC-V Software Ecosystem, and it is a group of about 20 member organizations whose goal is to provide support for the RISC-V software ecosystem. And that includes both engineering support, because each one of those members provides an engineer into the TSC, as well as financial support. The project collects dues, and then our biggest line item in the budget is to push that money back out into the ecosystem. And there's a little bit over 700,000 euros, I believe, currently dedicated to open projects. And these are, there is a process, an RFP process that is outlined on the wiki that anybody can follow. And the requests are evaluated underneath the TSC, generally under the working groups that are outlined here. Or if something comes up that isn't part of these working groups, then of course that's also evaluated at the top level. And we're very happy that this is continuing to be prosperous. And we're hoping for more membership. So if your organization feels like spending some money on the RISC-V software ecosystem, we feel that this is a good way to do it. The most important thing about RISE is that none of the work is actually held within RISE. RISE does not create any projects. We always work upstream, because upstream is where the action is, and we would not be supporting the community unless we were actually working upstream. So that is a basic introduction to the kind of RISC-V world, and at this point I would just like to open it up to anybody who has things that they would like to talk about with regard to RISC-V. This is a BOF, a Birds of the Feather talk, which means that we all get to chat rather than just have me talk on, because everybody will go to sleep if that happens. Anybody have anything to say? Oh, 1 second. We have just one thing also to mention. I believe we have people streaming and watching, so let's make sure to talk into the microphone so people can hear.
Okay. I'm sorry.
No worries.
Yeah, you have Ethernet controller on the chip.
It depends on which chip it is. That would be dependent on the hardware manufacturer who's designing the process, the SoC or the chip or the system.
So at this point, do you have any AI in the plan for RISC?
It's interesting you should mention that, actually. RISC-V has been used in a number of AI accelerators that are actually currently on the market. What they're finding is that even for a large-scale design, it is very effective to use something like RISC-V to create accelerators, because it's a completely open ISA. It's very flexible. It scales from a tiny chiplet all the way up to an HPC 64-bit machine. And there's a lot of opportunity there.
Jeffro, could you jump back one slide?
Certainly.
And I'll put you on the spot. And the work groups under RISE are doing some amazing work. Could you give us flavor? I mean, there's obviously a lot of details on the wiki. Give us a flavor of the 9 and what's going on upstream.
Flavor of what's going on upstream currently is going to possibly be outside my scope, but I can tell you exactly where to find it. All of the work that each of these groups does is outlined on the wiki, and we also give talks at the RISC-V summits every 6 months or so. There's one coming up in Europe in June in Munich, I believe, and there will be another one in the fall in the Bay Area in Santa Clara in October. So I encourage you all to chime in on those. And they're usually all recorded too, so the recordings will be out there. The most recent one will be out there.
That's interesting. So if we look at the members of RISE project, there are a lot of big companies, and so looking at what is being done based on the Wikipedia and meeting minutes and everything. So it's primarily focused around kind of a data center solutions. Is that correct?
I don't think that would be necessarily intentional. I think that's probably what is, I'm sorry, am I right here? I don't think it would be intentional to be focused on data center. Data center is one of the focus areas, certainly, but there are also members there who are interested in other aspects, certainly embedded, automotive. I'm trying to think of the members right now currently. We could just bring it up, actually.
No, I'm not arguing that there are members who are interested in other aspects or other areas. The question is how that work is being prioritized. Like, it is just a vote and more members want to do, like, I don't know, server kind of things, and that's why all the resources which are dedicated or contributed to the projects are being spent on that area. I mean, I'm a little bit concerned, so how can other areas also benefit from that? Because otherwise, so the thing is, so if some company joins RISE and expects to get some benefit from that, not only contribute resources, right? Everybody wants to get something. How can that company make sure that it will get something of their interest, but not only something for others?
Certainly, if there's something of general interest, it would be discussed in the TSC. All of the decisions for the work that is being done come from the technical steering committee. And there's a member of every single member within RISE has a membership in the technical steering committee. And I'm not sure that answers your question, though.
Oh, well, I think primarily, yeah. Thank you.
Yeah.
We heard earlier in a different talk that Yocto is one of the distribution or build system that does not support RISC-V yet. Do you see this as, is that one of the projects that RISE will take on, or do you want to answer?
Are there any Yocto folks in the room that could speak to that? Don't give Philip a microphone.
Okay. I am very glad. I'm very glad you asked this question. I'm going to be as diplomatic as possible. So, first of all, there's a lot of MCU class CPUs and things that are out there, right? So this is not Linux capable, but we've seen quite a few Linux capable boards out there. And everybody's asking Yocto project when you're going to have this officially supported. So during the final feature freeze of the Scarth Gap release, which is coming out this month, we had QEMU RISC-V being tested on the auto builder. We reached out to multiple community folks in the RISC-V community, and not one person, not one entity stepped up to actually join Yocto project as a member, because we need somebody at the Platinum membership to make that an officially supported reference platform. So no one stepped up to fund that. And we got actually a much worse response from an organization that is on the screen. And I'm not going to go any further because it will get political. So if you want Yocto project to have RISC-V support, we need you to approach whoever makes these decisions to actually get a Platinum membership in Yocto project, or else you will never, ever have it in Yocto project, because we can't do the work for free. It has to be funded by a Platinum member, period.
I would add that it's not just software work that needs to be done. There's infrastructure work there as well that actually does cost hard dollars. And so it's not been an easy problem. From the work that I've done on the Yocto project, it has been difficult sometimes to create support for specific platforms simply because nobody wants to enable software for their competitors. So that's one of the reasons why Yocto has been so popular, is because it puts that into a neutral place. And we feel that RISE can do something similar to that. So the question I heard you ask was, is RISE planning on supporting RISC-V within Yocto? And I can't give it a yes or no because those discussions have not ended yet, but they are certainly ongoing. And Yocto is a very important part of the, I want to say, compilers and tool chains, as well as the developer infrastructure working groups. So yeah, those discussions are definitely ongoing. And I have my fingers crossed because I have a vested interest in both projects.
So the fact that like Meta RISC-V exists, does that, and it functions fairly well, does that discourage that kind of actual pay-to-play?
Okay, so what do we need in order to have this actually be supported in Yocto project, okay? We actually need it to be constantly tested on the auto builder every single day. That means that we do it as QEMU RISC-V, QEMU RISC-V 64. So we enabled that, we tested it, we proved it works, and nobody, I know, but okay, yes, it's there, yes, it's supported, okay, by other community layers. But there's still a fundamental gap right now because it can't be officially supported by the project unless we have it in core.
My question is more, by that layer essentially existing, does that discourage somebody stepping, because they look at it and say it works, so why am I,
right.
why do I need to jump in and hey, enable it?
Okay, yeah, so, all right, so, perhaps, I don't know. I'm going to let Philip handle that one. Sorry. I'm probably already not saying the right thing.
So it's
doing good.
complicated. The answer to your question is you can sit there and you can build a QEMU image for RISC-V, and it basically works. I mean, I did this to show that I could run GNU Radio on RISC-V 1 or 2 years ago. It basically works. The problem is that if we turn it on as an officially supported thing, it runs through the auto builder tests, and if we have bugs show up, we don't really have anyone in a position to address the bugs, and will block builds. So, yeah. I mean, I'm just trying to make sure that we understand the underlying problem is we don't want to block builds without having people signed up to make sure we have the resources to fix them. Yep, it is strictly a resource problem.
I would say, to answer your question about does having a working meta RISC-V discourage that kind of investment, I would say no, because I think that companies are smart enough to see that a proof of concept exists, and it doesn't necessarily create a working project. So, and it certainly precludes things like testing and support, as Philip mentioned.
And when the first Beagle 5 development boards came out, I was one of the people that had that, and I absolutely can tell you, yeah, 100%, it worked, right? So we proved it with Buildroot, we proved it with the YOE distro, which is Yocto based. I proved it with ISAR also, because that was a place that we hadn't done it yet, and so we absolutely have all of the tooling and everything ready to have this be supported. We're just missing a few other aspects of it. And I think the resourcing, so Yocto project itself is already, we got some resourcing issues already as is. And so this is just an area where we have to make sure the resourcing happens before we can actually officially accept it as being supported.
One thing I can say as a semi-official representative of RISE is that having this conversation in this room is going to help the situation significantly. I can take this back into the TSC and the RISE board and make a case for Yocto support. So thank you all for bringing up a possibly controversial subject.
Because ultimately the vendors need to hear from you that you want it, right?
Yes, exactly.
This is actually the message.
Yep. The law of supply and demand requires a supply and a demand. So, does anybody want to talk about anything else? We have one right there.
So just want to start out, I'm not trying to salt the wound, but I caught Linus this morning at, I think I got in around like 9:07 in his keynote speech. And all I caught was he was just mentioning how he is pretty convinced that RISC-V is going to, quote, make all the same mistakes that x86 and all these other ISAs did. So as someone who only really has like a service level understanding of these different instruction sets, can you give me your kind of take on that and why RISC might be able to avoid those kind of things and what those silly mistakes that he mentioned might be?
That's a really good question, honestly. Kim, do you want to take this one? All right. Braver man than I.
Yeah. So yeah, I think everybody's open to their opinions, right? And you probably expect something, so you should take it that way. Essentially, what you look at is the way, if you look at how the hardware group is functioning today, right? So there are a lot of extensions being proposed. They are being discussed, ratified, right? And then if you look at the vector extension took so long, right? At one point of time, it looked like, will it happen or not? And then, there was a previous version and the next version came along. So what happens is, as you vet it more, right? So you are, you will naturally make less mistakes. As humans, we make mistakes. Whether we will make same mistakes again, that will be a little bit foolish. But if we make mistakes, chance of us making mistakes are a bit less, right? and there is more feedback you get from different people. So my hope is, and that's my hope, that you will come out with probably something that will have addressed some of it, but not all of it. So, and I think the extension groups are like exactly working in that fashion where it goes out for review, and everybody is open to provide their feedback. So you are not looking for like one silicon vendor or somebody to come up with like your next generation of vector extensions or some other stuff. So in that way, you can involve a lot more ideas, right? Whether all of them get implemented, maybe not. So that's a new way of doing things. I don't know how it's going to pan out.
And I would say that as some of the SOCs come out, that you have a problem with still have the vendor kernel tree problem. We're not seeing it necessarily hitting mainline immediately. There's one more up here, and then I'll come back to you.
So this started out of Berkeley. Do you have any information on other universities or schools that are pushing this as part of their program now?
There's a huge list on the RISC. If you look under the RISC-V members list, you'll see, particularly down toward the bottom, there is a humongous stack of logos.
And there's a university program as well. So I think there's a
university program as well.
Yeah, so you can connect to RISC-V Foundation, and I think they have specific programs for University Connect.
Yeah. They're here at the conference too. There's a booth in the back.
Yeah, they have a booth. Oh, okay.
So I actually wanted to answer the previous question.
Okay.
And I think Linus actually meant something like that. So we are here, we look at that as specifications, as a software people doing something. But what are we talking about, these extensions and everything? These are only specifications, right? But implementation is a different thing. And it's not that those vulnerabilities which we were talking about, Linus was talking about, they came out about due to the wrong specifications. No, quite in reverse. As Linus mentioned, it is all about all microarchitectural tricks which you do to increase your performance. And these things are being done by completely different people. Moreover, still, even if we are talking about RISC-V, most of implementations, they are proprietary, and these are big teams working. And so look at all of these companies which we had on the previous slide. All of them, they do proprietary implementations, and you won't be able to look at them and improve them or even review. And because still they want to have a lot of performance out of their silicon, they will still do most of the same tricks. And I'd say that there is state-of-the-art in that area, right? So everybody does. So if you want to be very performant, you will do out of order, you will do caches, you will do everything. And so side attacks, as Linus mentions, they are used smartly, like in the wrong way, used to abuse your implementation. So it won't go anywhere, regardless what kind of specifications will be written. And that's why, yeah, we need to educate hardware folks. Possibly we need to implement some tools which will try to stress test like we do with software. So there are tools which do fuzzing of something, so maybe something like that is possible for hardware development. But specification itself and software community cannot actually affect that much.
Yeah, so I think, we basically are looking for also like new ideas in there, right? So if you look at some of the companies who are new in this market, right, they have new tools and they do things differently. And they have like new design tools. So, yeah, I mean, we will make same mistakes if we put this thing into same processes, but I think the open nature of it kind of makes it possible that there will be newer ideas from like ground up. They will build things, and that might be, the forcing function, so to speak, that will make it do things indifferently. But you are absolutely right about like, there are other things besides ISA which define those errors, and they will still continue if we keep doing that way. So yeah, so RISC-V won't help in that regard.
I would say that there is a possibility to build on the knowledge that has already existed in the world. I mean, Intel has been around since 1968. They built a lot of the problematic stuff into the system and have also fixed a lot of the problematic stuff in the system. ARM has trodden a different path. But I think what Linus was referring to was the, I think that chaos is an appropriate word, of the chaos that was ARM hardware enablement in the late 90s in the Linux kernel. it was kind of the Wild West. And I will definitely give a call out, and it's not just because the CTO's in the room, but I will give a call out to Lenaro for solving that problem. And so the RISC-V, for one thing also, markets are stupid. They don't necessarily have immediate guiding functions. There's no central intelligence there. So you know, the ARM market may have made some confusion and chaos, but organizations like Lenaro, which is an open organization, are the ones that have been able to solve that. And so I believe that the RISC-V stupid market can also follow some of those same paths and make completely different mistakes. They will make mistakes, and they might make smarter mistakes, or they might even make dumber mistakes. They won't be the same. But we at least have the legacy of success to follow that ARM didn't have before, and that Intel didn't have before that. So I don't know if that's a good answer or not. Anybody want to broach a new subject?
So let's say I'm trying to make the justification to my company that we want to start using RISC-V, right? What, besides like the open nature of the platform, what are the marketing points, that I can convince the company that we should take on the risk of using this new platform that may not have tooling fully established for it, can't build it in Yocto quite yet. Well, I guess unless you use a meta layer. I'm kind of curious what your thoughts are on that.
That's a good question. And given that I never actually worked in RISC-V marketing, I'm not sure that I have quite the right answer. Do you want to take a crack at it? All right. Stefano Setole, everyone.
Not that I worked in marketing, but I'm happy to answer. So it depends on the company's use case, first off. What does your company in particular do? Like, would you be buying the SoC, or would you be creating the SoC?
Buying it.
Buying the SoC, okay. So that's probably the most common use case. And I think that is going to be one of the tougher sells. So if you look at the marketplace right now, there's not going to be a ton of vendors you can go to buy off-the-shelf SoCs. When I worked at RISC-V International, and people would come to me and say, hey, we're looking to build our own, there was a lot of options. When people were coming to me saying, hey, who is selling, that got much more difficult. But let's assume that market fixes itself in the next 5 years. Why would you use that? Well, I mean, I could certainly hand off to those companies to explain to you why you should buy from them. But as a former engineer, and as someone trying to think outside the box in terms of how to build products, RISC-V is going to offer opportunities that other architectures are not. Specifically, if you look at it compared to either ARM or my new company, x86 and Intel, RISC-V is going to be able to put stuff out there that Intel as a company is not going to want that market. They're going to look at it and say, nope, the thing you're doing, duct taping the vector spec to this other thing that you're doing, there's not numbers there that Intel cares about. So RISC-V will serve that market, and what's likely to happen is that the software infrastructure built up behind that concept will be much stronger, because you've got a company that's trying to change the way things are done in that particular way. So, I mean, I haven't addressed your question about the risk, no pun intended, and what you're trying to do. I think that's going to be there, but risk is inherent in innovation. If the company wants to try something new and do something interesting, there's going to be risk. And so the question is whether or not the concept is vetted by enough customer reaction. When you test, when you pilot that concept, is risk solving that problem in a different way? But to answer your initial question, it's that the RISC-V chip will solve a different problem, one that NXP, Qualcomm, and Intel aren't willing to do because the numbers aren't big enough, or because it's an untried market, and that's likely what you're going to end up doing. Does that answer part of your question?
Yeah, it does. Thank you very much.
Excellent.
I think we have time for one more topic if anybody wants to bring one up. We have put everybody to sleep.
I just mentioned that in the talk in the ballroom. RISC-V, I think, should create something similar to like Raspberry Pi, a simple board module and simple maybe just for something that people can use and just take home, plug in the computer, try it out, see the architecture, see the instruction set, and that way you can suck the people in to try it, and then maybe they can find out something like we just said earlier about mistakes and things like that. But I doubt it because for me, the first look I think is pretty solid. Anyways, yeah. So I think that's my suggestion. I just repeated what I said earlier.
Yes.
Kind of for
Yes. And there are a number of development boards like that out there, and I will give a shout out to the Beagle board folks. Oh, and here's one right here. Would you like to say a few words, sir?
Actually, the guys from BeagleBone just gave me the board.
Oh, okay. So which one is this? This is the Beagle V ahead. Yes, that is running a RISC-V processor. I believe that's the second one that's come out, and
That's the second one, and then there's the Polar Fire, which is the Beagle 5 Fire, I think is what it's called.
Okay. Okay.
What's that? Icicle.
Icicle? Okay.
Anyway, it's an FPGA. Yeah, it's a hard. Yeah. Anyway, it's another. There's three. Yes.
Okay. Excellent. So there are definitely options out there.
And so, like, I know, me personally, like, I'm just kind of waiting for the developer workstation so I can actually do stuff native, which is, at a kind of a level of performance that's, sort of there.
There are some of those out there.
Yes, so that's
there's the Milk 5 Pioneer as well.
And that's fairly new still, right? To me, anyway.
They're very new.
Yeah, because anyway, so like that's kind of one of the things like I was looking for, right? And so there's a ton of excitement, right?
Yes.
And we talk about this in the when you talk about it from the Yocto project community or the open embedded community or just the embedded community in general, we are all super excited. We're like really when's the next SoC coming out? What is it going to be? What is it? Is it on a board? Can I buy it? Can I buy it now? Like that's how we all are all the time, right? And I mean, I personally own quite a few of these. I think I just ordered the Milk 5, so yes. Yeah.
Okay. Well, I am not totally certain of the time, but it is 5:35, and I believe that we are ending at 5:35. Is that right? Yeah. So thank you all for coming. Definitely to go take a look at the Talk to RISC-V up in the booth area. If you want to talk about Rise, I will be in the Red Hat booth for the rest of the conference, and I hope you all have a good time. Take care. And thank you for helping out with the microphone. Again.